No one's going to say hi first? Welcome. I guess.
I thought you were going to say it. I mean, you had this big grandiose movement.
Well, I thought everybody would join in and say hi.
I went like that.
I was watching the feed on YouTube.
He's just
and
smoking
it hadn't
his pipe.
loaded yet.
You got some fine weed in that pipe? Shot from the Shire. The finest.
Yes.
Well, it's great that Brandon's all dressed up 1800s style, but nobody can see.
You can see. You can tell.
Well, I mean,
he's got a nice
realistically, this could be just like a normal Sunday for me anyway.
That's true.
That's true, because you are from the 1800s. How often has he worn
like a suit jacket on the show?
I have a tie on this time, though. It's a little different.
Yes.
He was born in the wrong century.
I don't want to be born in the earlier century. It sounds terrifying.
I mean, that's fair. I mean, 1800s.
That's rough.
I mean,
everything smells like poop.
Anything before like modern like sewer systems and
plumbing,
flushing toilets,
yes.
Plumbing is.
Didn't they? Well, I don't know. I'm surprised humanity got to this point.
Yeah, like Katie. I don't think Katie could have survived. She just would get sick. Right, Katie?
Oh, instantly.
Instantly sick in the before.
I love how everybody is going all in on the Easter thing. We got bunnies. We got
bunnies. We got chicks because it's Easter.
Right.
We're having a holiday.
Spock has risen.
Spock has risen.
Praise be.
As he should.
Yes. I thought that was great. I thought that was a great meme you sent. So.
That was a good one.
Well, you're running the show, right, Brandon? You're hosting.
Yeah. There's one update I'm going to make to this really quick because I didn't do research beforehand. And let's not do that this week. I don't know the photon thing, so let's cross you out.
Okay. We haven't Major Tom?
I was gonna do an update, but I forgot to do the quick math.
God, it's been so long since we've had an update for Major Photon.
I know, he's far away.
He's really far away.
Yeah. So, right. When did he start?
March 22nd, 2020.
March 22nd, 2020. So we're 3 years.
I like that track. Zombie Appreciation Day. Yes.
About 15 days. Okay.
Fancy physics, man.
7:30. All right, so 7:30. That's what it's almost it's almost 1,100 light days away. Oh wait, no.
Wait,
1,100 light days.
1,100 light days?
Yeah.
What is that in a distance that might be more comprehensible?
How many Skittles is that?
How many Skittles?
I mean,
how many Skittles can you eat in 11,000 light days? Even though it's a distance, not a time.
Okay, well, we're going to figure this out.
Save it for the show, people.
All right.
All right, there you go. I'm going to let you hold on to that.
Oh, I'm holding on to this? Okay.
I hope I have a calculator on this.
All right, he'll calculate. Brandon, you get the show rocking and rolling.
Okay, well, you know what you need to do.
All right. Ready in 5, 4.
Greetings and salutations. I am most pleased to welcome you to an extraordinary transcription of our humble show, Cosmos with Cosmos. I am Brandon.
I'm Liz.
I'm Mike.
And lend us your ears as we embark on a timely journey concerning the affairs of the modern 19th century astronomer.
Ooh.
Yeah, so this episode, you can't tell, we're going back in time. And we are looking at astronomy as it was in the 1800s, kind of focusing on the early 1800s, mid and a little bit late as well. It's a wild time because
it's the roaring 1800s. Yeah,
the roaring 1800s. They get science and astronomy just close enough to being right, but also wrong.
But so not right.
It's absolutely wonderful. All right, so before we gallivant into that century, we, of course, have to talk about our drinks. So, Liz, what are you drinking over there?
I am drinking the 19th century. All of it. All of it. Slavery and civil wars and all. I'm drinking it. And
all of the 18th century.
And this
What's that taste like?
It actually tastes pretty good, surprisingly, for the 18th century. Or 19th century. And inside of this drink, it has Lillet Rouge
Yeah.
Oh.
and bourbon.
It does. All right. All right. Lillet Rouge, bourbon. It has lemon juice. I'm missing something.
Simple syrup?
No.
Sugar cube? No? All right.
Yeah, that actually might be it.
That might be it, sugar cube.
No, well, I know mine has sugar cubes in it.
Okay. Well, anyway, it's a classic drink from the 1800s, in fact, called the 19th century.
It's the white cream of chocolate.
Oh, white creme de cacao.
Yep.
Cacao. Yes, and it's delicious.
I knew it. All right.
Well, as the vice president of the turn of the 18th century would say, bully for you.
Oh.
And also
No,
Ron
and
Swanson.
Yeah, Ron Swanson. Yeah.
Also meant the 19th. Now I keep getting 18th and 19th.
I know because it's the
It's
1800s, but
confusing.
it's the 19th century, so
Yes.
we're gonna have to pick one. What are you drinking?
I am drinking the plethora of planets because there were a lot.
Plethora of planets.
I just wanted to say
like
plethora. That's
Yeah,
all I
it's
wanted.
a fun word. It's a
I
fun
like that
word.
alliteration.
Plethora of planets. And it has bourbon and was it Peychaud bitters, along with a few sugar cubes, and you have a absinthe coated glass.
Absinthe coated
Yes, glass.
we got
Very
some
nice.
absinthe just
Yes.
for the 1800s.
Yes. Now I do have a glass of absinthe over here, but we'll see how well that goes.
Bourbon and whiskey were very popular in the 1800s.
Oh God, yeah.
Oh, yes.
Everything was bourbon or whiskey.
In fact, Brandon, what do you got?
Whiskey, as a matter of fact, was called the American wine.
Oh.
Fun fact. I was just watching the documentary on Prohibition from Ken Burns, and got all the fun details about that. But in any case, I'm drinking the Anti-Fogmatic, which was a drink in the 19th century, and it kind of did two different things from my understanding. It would help clear your head after a hangover with alcohol,
All right.
and it was a drink for bad weather. So the
Okay.
Anti-Fogmatic.
Oh, okay.
Nice. What's in it?
It is.
Hold it up a little bit higher.
It's just American wine.
Okay,
but,
so it's just.
but I may make an addition here live on air. For Mike was talking about the Sazerac earlier, and I have the ingredients of the old-fashioned in here, but I may add my own share of absinthe to it at the
Hey, there
moment.
we go.
Oh, just a beautiful
Nice,
sound.
nice.
I was waiting
waiting for
for
that.
it.
We're
I
gonna
was
have
waiting
our
for
own
it.
little Euro
So a
trip
little
here on
dash.
this episode.
Nice little
That's
dash
when I
in
first
there.
learned about and heard about absinthe. Was watching the movie Euro Trip.
Oh, there's that black liquor smell.
Yep, that fennel.
And I'm not going to
Fennel.
mix it because, I have a mixer on me right now, so I'm just going to go with it.
Go with it, man.
Nice.
So, cheers.
Yeah,
Cheers.
you know it. Cheers.
I do like your 19th century drink. Cheers.
It is good. Cheers, everyone out there.
All right, so with the drinks out of the way,
Hold on.
Jack is drinking
Of course.
a Current Sun tea that should have had another couple hours in the sun. But you know what, Jack? It still sounds good. My dad
It
used
does.
to. He would take his iced tea in the big the thing with the little spout at the bottom, and he'd have it sit outside
Okay.
and brew his own tea, and then he'd put it in the fridge, and then I would go in the fridge and I would go upside down and I would do.
That's
the
how you
thing,
have to do it.
And I would drink the tea.
That's the only
pour
way to
the
do it.
Tea into my mouth.
Yeah. Let's see.
and
All right.
podcast mom.
She's
is
got her
drinking.
Earl Grey hot.
Excellent.
Hot.
And podcast sister has a mango cider.
Nice.
Ooh, mango cider. That sounds
Yeah.
delightful.
By the way, Katie, tell Adam that I had one of those beers that he brought over when you guys were out for spring break, and that stuff was good, but it was thick. It was like a dark bourbon barrel aged dark beer. It was rich.
Well,
Anyway,
photon. I can't speak today.
Major
Tom.
photon?
Major photon.
Is 192.
Wait. No. We had to introduce the idea of major photon. It's been 3 years. So what did we do? What is its purpose?
Wait a minute. Did we not do that while everybody was listening anyway?
Not during the show.
Not this time.
Oh. Okay, so it was just us.
It was just us.
Yeah.
We were just talking.
Okay.
You know, what audience? No one needs
Okay,
context.
all right, go ahead. I'm sorry. Because you wanted to know, so I calculated it, even though it's going to be
All right, introduce Major Photon.
an AU wrong now.
Reintroduce.
So reintroduced, yeah. So Major Photon was a character, a concept we introduced back in 2020. And we just wanted to know, for example, how far a photon would get from the sun during a show. So, in 2 minutes we reach Mercury, 8 minutes we reach the Earth, 33 would reach, Jupiter, things like that. But then we kind of kept Major Photon going throughout space. And so once in a while for the first year, we would check in on it and see how many millions or billions of miles it was away from the sun. But we kind of let Major Photon linger. So we haven't checked in a very long time.
Linger. Sorry.
All right.
What's that from?
The cranberries.
Oh
yeah.
Zombie. on Zombie Jesus Day.
On Zombie Day, yes. So now from March 22nd, 2020 to today, Major Photon has gone how many miles?
Well, it has gone 1,113 light days away, which is 192,327 at this point AU, the distance between the Earth and the Sun. And hold on.
Hold, brothers, hold.
It is.
Oh God, that's a big number. How do you read that?
Hundreds, thousands, millions, billions. 17,886,355,200,000 miles away. But that was as a few seconds ago.
Okay.
So it's not even further now.
Yes.
It's even further.
Wow, it's really gone out there.
17 trillion miles.
Man.
So it has it technically officially left the sun's influence? Because it's nearing Alpha Proxima at this point.
No, it's only Oh yeah. I mean, it would be So it's outside of the boundaries of the solar system. It's beyond the Oort cloud.
Yes.
It's beyond
the
Oort
Oort cloud.
That's
All
crazy.
right.
3 years.
Man,
You go, little photon.
you got it. Oh, Major Photon. Jack says the green fairy Le Fée Verte has hit you already.
Yeah, and I've only had one sip.
Yeah. All right, let's go back in time, Brandon. Let's get to what astronomy was like in the 1800s.
Yeah, and we're going to go even further back in time. Like I had introduced social media and promoted certain people in the podcast before we start the show. So, for example, make sure to follow us on all the things. On Twitter at Drinking Cosmos, Instagram Cosmos with Cosmos.
Right. We gotta promote stuff. It's going the speed of light, Mom. She asked how fast it was going.
It's going the speed of light.
That's why they call him Mr. Fahrenheit. It doesn't matter. Of course, we have Podcast Sister with Delightful Arts, Wildixia on Etsy. Of course, Bron Proctor, who has our introduction to the hangover music at MrProctorShow.com. And the shot of the shot.
I really thought he was going to put it in his mouth, the pipe.
And, of course, Jack over there in Iowa at Rolling Bluffs Planetarium.com. Get the best planetarium in Iowa.
Roll on into his dome.
Bam.
Roll on in. Nice. And, of course, we do have rules for the podcast as well. Anytime Liz wants to skip a section, take a drink.
Anytime Liz isn't
Anytime
paying
you hear
attention.
a puppy bark, which may happen, there are multiple puppies at the Cosmos HQ. 4 puppies.
Four dogs.
Anytime
Only
you make
3 of them bark.
But in a month, there'll be 2.
Yeah.
Oh, and then there were 2. Any Star Wars reference, take a drink. That may be difficult, as this is now a podcast set a long, long time ago. And, of course, any Lord of the Rings reference, take yourself a drink as well. So with that, I believe it is time to venture back in time. And as they would say in the Wayne's World, diddle-doo, diddle-doo, diddle-doo.
Diddle-doo.
I guess I'm holding this.
Yeah, you like to hold it. You're good at keeping track of stuff.
All right, so one of the big questions in the 19th century, the 1800s, is what does the universe itself look like? What is the universe? How big is it? Is it just that big Milky Way? What's going on?
Yeah.
So I kind of wanted to start with the shape of our understanding of the universe.
Okay. It's weird to imagine the universe with a shape. I will put that out there first. Even
I got that.
because it's just
like a Pringle.
That is the current known shape, right?
Yes.
Like a saddle, like a
saddle, yes.
like a horse's saddle, which is weird. and I can't think about it too long, or else my brain starts melting a bit.
It folds in on itself and it gets very confused.
Yeah. So I mean, what were people thinking the shape of it was? Because I would assume people are thinking about the Earth and stars and that they're spherical, so they're thinking our universe is spherical as well.
Right. So at the turn of the century, the best known shape.
You had your mom at Saddle.
I had my mom at Saddle.
Right.
Yes.
I was thinking the same thing.
Really?
I'm
I'm paying attention now.
Can we write it?
Ride the Universe.
Oh, we're writing it as we speak. All right, I'm sorry, Randy. Go ahead.
No, that's the name of my next album, Ride the Universe.
Metallica might sue you for that. It's a little too close to Ride the Lightning. I don't know.
Oh,
Lightning's...
Ride the Universe. Ride the, it's 2 words. You can't.
All right.
Yeah.
Well, in any case. So the universe, as we understood it in 1801, the shape and size of it really came from 2 individuals, my favorite astronomers of all time, William
Herschel.
and Caroline Herschel, whom I will take a drink for at this moment.
Cheers to the Herschels. It's also a fun last name to say. Also, sounds like Hershey's.
And I still haven't done the shot on them because I'm just waiting. I'm just building it up. It's going to be fabulous. So do not take them.
Oh, I already did. Sorry.
Gasp.
No.
So in any case.
But you can check out our recent shot episode on Edwin Hubble coming out in a couple weeks.
Bro, ruin the surprise for me. Why don't you?
Okay.
All right, so William and Caroline Herschel, they were the foremost astronomers of their day. They started really as amateur astronomers and eventually got the king involved and all this money and then became royal astronomers. And so they would spend night after night after night after night surveying the sky and marking down each star's location.
I mean, how do you not lose track of what you've already looked at,
And
what you've already marked down?
Meticulous notes.
Huge notes. Caroline would, organize them, and William Herschel had a phenomenal memory beyond photographic. I don't know how you can remember all those millions of stars.
Yeah.
But yeah, you can look through his notes, and just the detail is incredible. But the one thing he did is he made the assumption that all the stars' luminosity, the brightness, was the same throughout.
Oh.
So every star basically is supposed to be as bright as the sun. And from there, you can judge the distance of how far away those stars are. So the thinking went. Because, of course, how else do you think that stars change brightness?
That's true. I mean, you really don't. I mean, at that point, you only have one data point, and it's our sun, for a star that's nearby. So, I mean, it's fair to assume, I suppose, that, all the other stars are like the sun, because why wouldn't they be?
Yeah, and at that point, the largest telescope of the day wasn't really usable, but it was called the Leviathan Purcellton.
What?
The Leviathan?
Leviathan, yes. Leviathan.
The Earl of Ross. It was a 75-inch telescope. It was huge.
Wait, it's called
massive.
the Earl of Ross?
The Earl of Ross was the man.
Oh,
and he had an observatory, and it was called a Leviathan. And it was basically...
Leviathan is such an 1800s.
Just think of some, church ruins from Elden Ring. That's what it looks like this telescope was sitting in. And it had all these pulleys that you could raise it up and down and all that kind of stuff. And...
But as you can imagine, because everything moved, having pulleys and cables move the telescope with the sky was just really unwieldy.
Well,
it's difficult.
yeah, I mean, but I
have a tiny 6-inch telescope, and I have a difficult time keeping it up with the moon.
Yeah.
Yeah, but they were able to get some amazing drawings because they would draw at the time. Like with that, one of the spiral galaxies, Ursa Major, I think. I don't know. It's one of the Messier objects. And just really incredible detail. You really can see the spiral shape in the drawing.
Yeah, I mean, Google like old, astronomical drawings, and it's really amazing that people.
This is where I wish we had all our pictures from the 1800s.
I was just thinking
I know. Those would be really a good example of.
It's in storage right now.
Yeah.
Waiting to make the move.
So that was the biggest telescope of the time. The telescope that the Herschels were using was only 50 inches, which is still significant. Mm-hmm. They made all the mirrors themselves as well, which is quite neat.
And this is 200 years after the invention of the telescope by Hans
which was
and then made famous by
1.2 inches of Galileo's telescope to suddenly 40, 50 inches.
And they were using refracting telescopes, correct? Was this a refracting telescope then? Using mirrors and not lenses?
I think the Leviathan was a reflective.
Reflective, okay. I meant reflective, not refracting.
I think it's reflective. I'm either right or wrong on that.
You got a 50-50 shot.
A couple of choices. It's not like
I'm going to assume it's reflecting, which is what I meant, using mirrors, versus refracting, which uses glass lenses, which are more heavy and unwieldy and hard to make telescopes. It's hard to make a big telescope with a glass lens.
Mm-hmm. So in that case, they used those limited telescopes, even though they were sizable at the time, to map out the stars, but with the belief that each star had the same intrinsic brightness to it. And so with that technique, they kind of made this map that the best I can describe it is like spilt milk on a table. Like it's like you take a drop of milk and you drop it and it splatters on the table. That's kind of what it looks like.
Yeah, it's not circular.
It's like because they're basing the shape of the universe off of the distance of stars, which is based off their assuming the luminosity is the same as the sun.
Yeah, and to be honest, though, I mean, you got to start somewhere.
You do have to,
And it's all.
And this is pretty advanced astronomical science for this time.
Right,
to
and
be
so
able to
everything
do
you
this.
make is. With science, you have to make that initial assumption, and then you kind of test it and go from there. But yeah.
Is there any
bug splat? I love that. So Jack says on YouTube there, they call it the bug splat.
Oh, yeah. Is it in some museum somewhere? My mom asks.
I'm sure it's in his notes, and that they just have it stored somewhere. But you can look it up online. Herschel's map of the universe, and it's a tattoo I really want one day.
A question, and I'm sure we've talked about this ad nauseum or have brought it up. But when did we first figure out? Oh, wait, stars have different luminosities in order to get. Was that with standard candles or?
That's a good question.
Does anybody know?
Let's find out as the century goes on.
Okay. Let's do it.
So a couple of interesting things did happen with that map, even though it looks like a bug splatter. Number one, because there are, the amount of stars anywhere you look around Earth is the same. That put us in the center of the space that Herschel saw. Only because anywhere you looked, the distribution of the stars was even throughout. Mostly.
Mostly. Was anybody like, well, we're probably not at the center of all things here at the end of...
based off the books I have read.
Does that count?
So based, which is what a lot of these notes come from. They always say, based off of these measurements, the Earth is, in the 1870s, they say it's in the center north of the center. So it's not quite, but it's near the center. But they're just limited technology at the time, which they were limited to.
Right.
That's all they can do.
That's true.
But an odd thing happens with these maps, especially in 1801 and 1876, is that because a lot of these stars are within the Milky Way, obviously, the plane of the galaxy, the map is stretched out lengthwise. So it's like a bug splatter that was traveling fast. So it's stretched out lengthwise to kind of make up for that stretch of the Milky Way in the sky. So they were kind of getting it right. They're on the right track.
They're on the path. Yeah, they're on the track. They're like, okay.
Yeah, so if we fast forward then to 1876, at this point, with many more people making observations and measurements, we have 18 million known stars. And 15,
that is just so many.
I know.
It's
so many at the same time, so little.
I still don't even know.
It's nothing compared to the size of the galaxy.
My brain still can't comprehend being able to keep track of these stars. I know that they're always in the same position every night, and there's definitely no light pollution or a limited amount of light pollution at this point because it's so
candles.
I'm sure you have.
Electricity is not widespread.
Yeah, you're not going to have all the streetlights and everything, so you just see, but just to be able to... even with a telescope, when you look through a telescope, whether it's tracking or not, things are just, you really can't tell what you're... us trying to find the green comet that was around last month with binoculars, I was like, I don't... And I'm trying to, use, I take the binoculars down, I'm like, okay, here's where I'm looking, and then I put them up, and I'm like, I don't know where I'm at.
Sometimes it's difficult to find the moon with a telescope. that's the easiest thing to find.
Yeah, right? So, I mean, this is really a feat for these people to, I mean, spend their nights just looking at the sky and trying to and actually get, like, this many stars cataloged, and they're not,
18 million. There's
18 million known stars.
200 to 400 billion in the Milky Way alone.
Yeah.
And so 18
this
million.
is a fraction, but also...
It's a fraction of a fraction.
This is cataloged with just people, like, looking at the sky and being like, boop, 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 marking dots down.
18 million little data points.
And if anyone is curious, so when I say 1876, I say a specific date because I'm referring to a book called The Elements of Astronomy, written by the guy who co-discovered helium and founded the magazine Nature.
Oh, that's fun. Co-discovered helium.
And Brandon, where did he discover helium?
You mean like on Earth? Or like he was looking at the prominence of the sun.
Yeah, so helium was discovered on the sun before it was discovered on Earth.
Wait, it was discovered on the sun before it was
that's
discovered.
Why it's called helium.
And then we were like, hey, let's put it in balloons and then breathe it in and make our voices all funny.
We had to find it on Earth first. But yeah.
How did we find it on Earth?
Spectra.
Where do we...
It was, I forget, I believe it was a Frenchman.
Prospector.
Or maybe it was an Italian. Hopefully Federico's not listening to this. Who was observing some kind of, crack within the Earth and looked at the spectra of it and noticed that the spectra lined up with the same spectra they saw in the sun. There's helium.
Yes, and just as a refresher for everybody, that each element has its own spectral fingerprint, basically.
Mm-hmm.
Wow, that's pretty amazing. Yes, helium, Helios.
You know who was one of the major people with spectroscopy, so to be able to measure that light in stars? William Herschel.
Oh, okay.
So in any case, if we fast forward to 1876, thanks to the book, of the 18 million known stars, 15 million of them lay close to the Milky Way. So that band of strip.
Okay. So basically, most of them are on the plane of the Milky Way.
Yeah, which makes sense because in their mind, the Milky Way and the universe is synonymous with each other.
Right. And this is well before we figured out about different galaxies and all that.
It's getting to the point where people are starting to question, this is the known universe, but there is an object, at least a couple of them, that appear to be so far away that it may be outside of it. But there are some people that refute that. So, for example, the Dumbbell Nebula. Yeah.
The Dumbbell Nebula.
The Dumbbell Nebula, yes. So at this point, we had ideas as to what nebulae were, and we'll talk more about that later. Mm-hmm. But the Dumbbell Nebula in particular was believed to be so far away, it lay outside of the universe, they call it, outside of the Milky Way.
Okay, so at this point, the universe is basically the Milky Way.
Yeah, again, we go back
that
the Milky Way is the universe.
Okay.
And it's funny, in the book as well, they surmise that there may be other universes. Like, you guys have no idea.
Oh my God, it's so great. It's so... I mean, and this is not... I mean, historically speaking, this is not that long ago that we're like, the Milky Way is the universe.
At this point, the National League was founded in baseball, so it's just not that long ago.
Jack says...
Jack
says, so much helium was found in a deposit under 5th Avenue in NYC, it was quickly claimed by Rowland Macy.
Nice.
Roland Macy. I will pronounce it Rowland.
Okay.
So getting back to 76 and the shape of the universe, because we haven't talked about the shape yet in 76.
We haven't.
So at this point, because 15 million are in that band of the Milky Way, it is believed that the thickness of the universe is small compared to its length. Mm-hmm. So they're already getting that there is a Milky Way and a shape to it, that it's not that thick, but it's incredibly long. Mm-hmm. So you can see they're getting inching ever closer, and it's absolutely fabulous. And again, this is where they believe the stars are mostly evenly distributed, but the sun and the Earth sits a little bit north of it. What are we laughing about?
Yeah.
I'm trying to not be a middle schooler at everything you're talking about.
Okay.
What am I laughing about?
No, just
everything you're talking about.
Continue
I'm
on.
trying not to be a middle schooler.
Continue on.
I'll let you think about the phrasing of what you were saying.
Oh my God.
Just continue on.
Didn't Herschel discover Uranus?
I got really
This is a family show. All right. Anyway, continue.
Yes.
I would be like crotchety old professor, like, why are they laughing? So the shape of things
we draw penises everywhere.
Right? The
The
shape of
universe is
things,
the shape of
Liz, are not that thick, but quite long.
Okay. Thank you.
All right, so that brings us to the sky, the night stars.
The night sky. The night
The
stars.
night sky, yes. So we know there are roughly 18 million stars in the universe, as we know in 1876.
In 1876, 18 million stars. Cool.
And they, of course, have different colors. What colors of stars out there, Liz?
We got blue stars. We got, your orange stars. You got your red stars. You got what look like white stars.
One of my favorite things is instead of red stars, they call them scarlet stars.
Oh,
Ooh.
that's so 1800s.
Scarlet stars. Isn't that lovely?
Scarlet. Yes.
I love that so much.
Scarlet stars. I like that.
And according to, the historians in 1876, these stars change color over time as well. So, for example, the star Capella was red in ancient times, but is now blue. And the star Sirius was red thousands of years ago, but is now, as they say, green. Go on, Liz.
It didn't really change color.
What? How?
No,
okay.
It was our perception of it that changed.
But how?
Yes.
I don't know how Sirius could look red to ancient peoples. Are they just going off a record? Are they just going off of just?
Well, after a bunch of wine, you pick a color.
After a lot of American wine,
Well,
it doesn't
I'm just
really
thinking
matter.
for Sirius, I would think that like the ancient Egyptians or the Greeks, they wouldn't record it as being red.
Well, also keep in mind that the kind of definitions of colors slightly change over time as well. So, for example, in the Odyssey or the Iliad, whichever one was first, I guess it was the Iliad.
The Iliad was first, yeah.
But written
By
anyway.
Homer.
Anyway, yep.
Anyway, so the color of the sea is described as red. It's consistently throughout. And it's clearly not the case because the sea is not red. It is
But maybe
bluish.
that was just like a writer's,
No. So there are multiple instances as well of the sea being described as a red color. So even the definitions of colors have changed. So I think in this
weird.
case,
Okay.
so in this case, it may have been red, but was always probably
But
blue.
it was always blue.
Yeah, because
Okay.
it takes extraordinarily long, as we know now with the HR diagram, for stars to change color like that. It's not going to happen in the course of 1,000 years.
Yeah, and for example, for Sirius, it's a blue giant. It will eventually. Will we notice it turn red as it goes through its life, or it will just supernova? Because it would because Betelgeuse is going to supernova.
Yeah, it's going to supernova, but still, these are. You're talking long times.
Yeah. So okay, that's just interesting that I never knew that there was such a disparage in color. Discrepancy. Thank you. Discrepancy. That's the word I was looking for in color.
Yeah,
between things that have been the same color since time immemorial because their lives are so long compared to human existence.
Well, yeah, but I think the problem is that we assume that people 2,000 years ago defined colors the same way that we define colors.
Okay, that's fair.
Mm-hmm.
That's fair.
That
Yeah.
we see
right.
things. You can even say the problem is like 200 years ago we think that. We feel like that. We just feel like obviously
everybody's seen the same things.
Thing.
Sees things the same as we see them. Okay, I got you.
Yeah. Oh, and just as a side note, the sun puts out most of its light in the color green. But it does not appear green from your backyard.
Yeah. Interesting.
Yep.
Oh, I wish it was green. All right. Anyway, continue on, Brady.
So in 1876, we knew that stars changed color based off historical evidence, and the modern day, which is not right, but then it was. But also, we know it changes sizes. We'll talk about that in a moment. Why does this happen? They say they do not know. They have complete ignorance.
Okay, and they're I would assume that they're confusing their definition of size with like maybe luminosity.
Correct, because Tycho Brahe, the new
Good old
star,
Tycho.
Not from the 1800s.
no, a couple centuries before that. Tycho Brahe's the observation making of a new star in 1572, where in his notes he describes the star going from white to yellow to red with an incredible change in brightness. Now, of course, today we know what the hell that was. We know that was a supernova.
Yeah.
But that wasn't going to be coined until Fritz Zwicky comes along, decades later. So to them, the stars just change color and size whenever they want, and they're not quite sure why or how.
Whenever they feel like it.
Meanwhile,
I mean, it's just like the stars of Hollywood,
Meanwhile, they like to argue that the universe is unchanging. Anything out beyond our atmosphere is unchanging, but clearly it is.
As Aristotle would say, maybe that changing actually happened within the Earth's atmosphere, because the Earth's atmosphere can change, clouds and lightning, things like that.
It's true.
But I think we were a little beyond Aristotle in 1876.
Just a tad.
Yeah.
Just a tad. Just a couple of years.
Though, I mean, Aristotle has a pretty strong influence still.
Still.
It's weird how much of an influence
1800s.
that Aristotle has when he was so wrong, but it was the first steps into tiptoes into modern science.
And even in these 19th century books, he's mentioned, because of course Kepler's mentioned as well in Kepler's pursuits of planetary harmony, the harmony of the spheres. So even now, even in the 19th century, you still have the impact felt of the ancient Greek philosophers.
Right.
Yeah, I mean, you could argue he set us back a long time.
Well, we like everything to be in nice, neat little spheres.
What's that?
It'd be nice.
We like everything to be in nice, neat little spheres.
Well, I mean,
That'd be great.
I mean, it really would be nice, but
we have OCD as a species.
But there probably is a multiverse universe somewhere that has little spheres. Everything is in spheres.
There could be. Anyway,
I'm
Bring
just
us back, Brandon.
Bring us back. All right. So those were the stars of the 19th century. But of course, in the sky, there are things other than stars, such as, let's go with nebulae. Nebulae. So nebulae, of course, it's a Latin word signifying a cloud, which makes a lot of sense. If you look at the Orion Nebula today through a telescope, it looks like a green cloud just hanging in blackness. Gorgeous.
Please go see it somewhere
beautiful.
and observe it. I mean, it's amazing.
I remember the first time I saw it. I still remember the first time I saw it through a telescope.
Where were you?
I was in my astronomy class at Arizona State West University.
Okay.
We went out to the dark area in the desert, took the telescope. Like, holy fucking shit.
It was Alamo Lake State Park for me when we took telescopes up to Alamo Lake State Park in Arizona.
The Melton Observatory on the University of South Carolina campus in Columbia, South Carolina.
Mm-hmm. But these were telescopes that were far stronger than they had in 1876.
Yes.
Had better resolution, I'll say, not necessarily stronger. So, for example, as the telescopes grew in strength in that century, they could look through at these nebulae, and they would be resolved as mostly clusters of stars.
Okay.
So they kind of figured that all these nebulae are just star groups out there.
Okay, yeah.
Yeah, different distances away. But in 1876, they figured out that, quote, a true nebula is a mass of glowing or incandescent gas rich in nitrogen and hydrogen.
Oh, wow.
But nothing else. Just hydrogen and nitrogen.
How did they get the nitrogen and hydrogens? The spectroscopy?
I believe that is the case. Hydrogen would be easy enough to see.
Yeah.
Actually, so for those of you on the podcast here with video, my book from 76 has a fold-out of spectroscopies.
Yeah, so...
I mean, of course. Oh, look at that.
Look how cool that is.
If you're listening on audio only, look at our YouTube channel and you can see that.
Yeah, so it has the Sun's spectra, Aldebaran, Orion's, Nebulae 37H4, and sodium. And you can see the individual lines pointing at hydrogen, iron, nitrogen, magnesium, iron, sodium. It's quite cool.
That's amazing. Yeah. Okay. It's cool.
So we knew there's some gas involved because we can see the spectra there. But in the late 19th century there, we kind of figured out there were 5 types of nebulae. We have the irregular nebulae, which is like the Orion, which at the time was also known as the Fish Mouth Nebula.
Oh.
Because with the resolution that it had, it kind of looked like a fish mouth.
Okay. I've never heard that.
Don't you ruin our nebula, man. Don't you do that. That's our nebula.
So the Fish Mouth Nebula was in the regular nebula, as was the Andromeda Nebula.
Oh.
It was in the same class as Orion.
The Andromeda Nebula in the 1800s. Okay.
And then you had the Ring and Elliptical Nebulae. And then you had Spiral.
What's
or
the elliptical
Whirlpool.
Nebula today? Is that the Helix?
The Helix Nebula? Possibly.
Okay.
Well, of course, the Ring Nebula is easy enough to know.
The Ring Nebula, yeah.
And then you had the Spiral or Whirlpool Nebula.
The Whirlpool Nebula.
Yep, and that comes from the galaxy they were seeing that looked like a whirlpool. They called it just a nebula.
Which today is known as the Whirlpool Galaxy.
That's correct. Planetary nebulae and nebular surrounding stars.
What? Wait, hold on. What was the definition of planetary nebula back in the 1800s?
I didn't see a definition. It was just listed.
Okay.
I'm thinking that the Ring Nebula looks sufficiently different from like a spherical thing like you would get with Planetary Nebula. Mm-hmm. Because the whole idea behind a planetary nebula is it looks like the disk of a planet through a telescope. Okay. So it's going to be circular. Mm-hmm. So I'm thinking the Ring Nebula probably is not.
It's not the Ring Nebula.
Is not so.
It's not today's Ring Nebula.
Probably not.
Yeah, and so that's why I ended up getting into this elliptical.
Interesting.
Category. That's my thought. I don't know how true it is or not.
So my mom asked, no question is a dumb question, Mom.
What do you look through to see the spectra? I would suppose.
Yeah. Do you see that through the telescope?
Basically, the light passes through a prism. You have to separate it out. So
look at Jack go.
It's called a diffraction grating. It's like those glasses they give
yeah.
I never got glasses at a fireworks display.
If you remember your chemistry classes in college or high school, they would light the beaker or pipe, light that's.
It's like the ones at the toy store. You could put the toy store ones on and look at the lights, and you can see the rainbow coming off of them. And,
so you get the spectrum.
And that was my favorite. Actually, that was my favorite lab that we did in my astronomy lab when I was in community college. For my astronomy class, was the spectroscopy lab, where we had basically tubes of various gases, and then we would put on the glasses and look at them through the light, and through the glasses you could see the absorption lines, and then you would use a chart to try and figure out what gas it was based on the absorption lines that you were seeing through the glasses.
Absorption or emission lines?
I don't remember, one of them, but
well, they're very different. They line up though.
I just thought it was really cool that you could actually see, and then you could look at it.
If it's a dark band and a continuous spectrum, they are absorption lines.
Yeah, it was absorption lines.
Okay,
yeah,
so,
it was absorption lines.
But if it's individual little lines, then it's an emission line.
Yeah, and so they do that. They do that to see to basically look at the fingerprints to say, okay, what is in this, and they can tell based on either the absorption or emission spectra exactly what is in there based on kind of the different wavelengths of light that are either absorbed or emitted. Essentially.
And we still use that in science often, all the time today.
Yeah. Mm-hmm.
In your readings of for this, did they say how they at the time how they understood absorption and emission lines?
So I didn't have any emission examples, but with absorption, I'm assuming it would just be example after example, seeing the same thing after same.
I meant what creates it. So fundamentally, you need quantum physics to understand.
Oh. They didn't have quantum physics in the 1800s.
Exactly. So, were there any statements as to how these arise?
Nothing that I saw. I'm sure they do. And after the show, when I sober up, I can look through these 150-year-old books. I don't want to do it right now for obvious reasons.
Only Brandon has 150-year-old books.
Oh, that's it's like the youngest book I have. Wow.
All right.
So in any case,
but that comes from Newton, though, right? Spectroscopy.
Well, no. You need quantum to be able to describe it, and so.
But to be like, oh, this element.
Oh yeah, no. That would could potentially go back to Newton. I don't know.
And separate the line out.
Right. But the fuller understanding of why, not necessarily.
The why they don't know, they go, oh, that just is. Oh, that's that.
Yeah. So.
Yeah, that's the ethereal package of the unknown.
All right.
Okay.
Sure. All right, so coming back to 1876 here. So these different type of nebulae, because at their understanding, most of them were compact stars extraordinarily far away. This is where the debate begins about, is the Milky Way the universe, or are there objects outside of the universe?
Oh.
Yeah, so saying if there are this many stars compact together, they cannot be as close as we think they are. They must be further away. And that ultimately, comes around in a great debate, which we've talked about before in the 20th century. But this was just the tease, if you will.
The inklings, the
inklings. Yes, the inklings of
Wait a minute.
the universe is far more vast than we can possibly comprehend. But for right now, 20 million stars.
Wow.
Give or take.
I mean, but we're focusing largely on people that were in the northern hemisphere.
Oh, yes.
So you could get a completely different set when you're in the southern hemisphere. Once you get so far below the equator, you don't see things in the northern hemisphere.
Only because the distribution of stars is still going to be mostly even throughout any hemisphere, except with most lying within the Milky Way. They do talk about the large and small Magellanic Clouds, the small and large Magellanic Nebulae, as they're called.
Of course.
And say that these are pretty big, and they may lay outside the universe as well. There's no, they say, however, there is no evidence that they are part of the structure of the Milky Way.
Well, and that's true. They're not.
Yeah. So they're just on the right path. They just don't quite have the right technology.
Yeah. Oh gosh. It's like so close. But then at the same time, then it makes me wonder, well, we think we're right there on it. How far are we going to be off, based on future technology and future science that we can't even comprehend yet?
In 200 years, there's going to be a Cosmos podcast happening.
200 years? Okay.
In 200 years.
All right.
And they're going to talk about 21st century astronomy and physics.
We are what? 29 years and 364 days away from first contact, I think. Isn't that right?
Oh, actually?
First contact day was like yesterday, I think. Or 2 days ago, maybe.
Yeah, I saw a social media post about first contact day.
Yeah, so we're close.
Oh gosh.
But you know what happens? You know what happens between now and then, though.
We're
close to that too.
That's looking off into the future. We are looking. Take a drink a long, long time ago. Because up next, we're going to talk about our understanding of planets in the 19th century. So at the turn of the century...
We've just been focusing on stars. Jeez.
I know, we're not at the planets yet.
We have a whole universe to focus on.
Oh, I thought you were going to talk about the sun next.
Oh, I was looking at time. We can go back to the sun if we want to.
Oh, you know what? Everybody is enjoying this.
We're enjoying it, which is really what matters.
Well, you're in charge, so you do you, man.
All right. So going back to so we talked about the nebulae, the cluster of stars, most of these as understood, and the stars, all 18, 20 million of them. But there is, of course, one star much closer to home that we can study a little better, the sun.
The sun.
Hooray. And thankfully, in the 19th century, we understood that the sun was a star, unlike many adults who would vote in Treehouse Adventures.
Yeah, I'm very disappointed at... Okay.
You have to explain that reference.
Yes. So when we were in the planetarium together, we'd have a children's show called Treehouse Adventures. It was the most adorable thing. Mm-hmm. The kids loved it, I think. We loved it, and it was great. But during the show, we would ask questions. One of the questions would be like, okay, what does this cloud look like? Or, what does that cloud look like? Or what is the sun? Is the sun a star, a planet, or a moon? The amount of adults who seriously said the sun is a planet is not zero.
No,
it's not zero. And the amount of adults that answered that question wrong is not zero.
Because you would hear they would go, oh no.
But we would have that as like a trivia question for walk-in for shows because we have buttons on the seats and people could answer the trivia questions with their buttons while they're waiting for the.
They don't take care of it.
Yeah.
And
the amount of people that got that question wrong.
Oh yeah. But
at the very least they were like, oh well, let's know more. It wasn't like when the church troops came in and said, cover your ears as we talked about the Big Bang.
Yes.
Oh yeah, or when they would tell us that we couldn't talk about certain things.
Yes.
And then we would talk about certain things.
Yes.
You kidding me? We're going to talk about certain things.
Do what we want.
Yeah, but anyway. What does old chap William Herschel do in 1801?
Oh, in 1801, my old chap William Herschel, my best buddy, he discovers the temperature of infrared. So Newton knew, of course, that the prism could shine out light into various colors. But then William Herschel stuck thermometers on the ends of them and saw that the temperature changed as well.
Oh, that's interesting.
Yeah, so he would run the thermometer over each of the colors, and he went off.
And he
went off grid. He went off script, just a little bit to the right of the red, and the temperature spiked.
And he went, whoa, there's something here I can't see.
Yep.
If
that's causing.
Remembering this correctly, maybe you can correct me on this, but I think he was writing down the temperatures and just kept the thermometer in place and didn't bother moving it. When, of course, the sun moved, the colors changed, and it hit that infrared spot. I'm not sure if he did that on purpose or if it was a mere accident.
Either way, he discovered the infrared.
That there's light we cannot see.
Yes. In fact, there's a lot of light we can't see.
And that is just, the infrared is just the whisper of the rest of the universe. Just knowing there's beyond.
Okay, take a drink to that.
Whisper to the rest of the universe. That's a beautiful quote.
I've been writing more, so things come out better. So we're understanding now.
I want that as a tattoo somehow. Okay.
Hey.
I gotta remember that for later.
Well, just watch the podcast.
There you go. Somebody has to. So we are understanding now that the sun is more than meets the eye. That
just like Transformers.
I thought you'd appreciate that.
Thank you.
We're understanding that it gives off more than we know at the time.
Yeah.
And so moving forward another couple of decades, we realize that the sunspots, the activity on the sun, gets busier and decreases in cycles. Heinrich Schwab in 1843 discovers the first solar cycle from his notes and realizes these things change in a cycle or cyclical over time.
You got to study that for 22 years.
Oh, multiple.
Yeah, because you have to confirm it.
I mean, you got to confirm it.
Because it's 11-year cycle.
Yeah.
Yeah, so you got to confirm it.
I'm assuming that Heinrich had his notes and looked at other notes as well, because surely there are solar notes from the last couple of decades.
Oh, yeah. People were measuring the sunspots.
Mm-hmm.
Because I think Galileo was one of the first to see sunspots.
Well, yeah, a telescope.
Yeah, but he projected it, I believe.
Yeah, because you can't look directly at the sun.
I mean, you can.
Well, you can, but it's gonna.
You can, but
suck for your
you're not
eyes.
gonna see anything after.
You won't look at it for much longer after.
Yeah.
Yeah.
So we have the temperature of infrared, we have solar cycles, and as we talked about in 1868, we discovered helium using spectral lines of solar prominences. So it gives ideas and clues to the inner workings of the sun, because now we know that there are cycles. We know that there's helium involved, lots of hydrogen as well. We obviously don't know that hydrogen atoms are slamming into each other to produce helium over time.
We don't know the nuclear fusion yet.
We need quantum for that.
Yeah. But again, you can see how once you kind of put these things together and figure it out, like, okay, there's lots of hydrogen, a little bit of helium, and then all these lesser elements in the sun, that maybe they just, combine over time, and that's that. Which is why at the turn of the 19th century, towards the 20th, they were thinking, well, we kind of have all this stuff figured out. We know kind of what's happening. We know the end results, and we're close to the end.
Close to the end, guys.
Yeah.
We got it. We did it.
We did it.
We did it. We figured out the entire universe.
What's the quote, Mike?
The quote is that physics is going to now become biology, where we're just classifying things. And guess who comes along a little bit later on? Planck and Einstein, and just fucks that shit up.
Motherfucking Einstein.
Yeah, but Planck is the one who really threw the monkey wrench. And so, what's crazy though is you're looking at these. We're 200 years removed. At the end of the 19th century, we're 200 years removed from Newton. And thank you.
You're welcome.
Was it a hair? I was gonna die.
No, it was like a little.
He had a facial prominence coming out.
Yeah, and so what was the thought among physicists where? Okay, so we have all these stars. We know that gravity exists, and we understand gravity through the lens of Newton. How come the universe is not collapsed in on itself? So you have this bug splatter, this milk.
Love that.
this milk drop map that Herschel came up with at the beginning of the 18th century, but still that's 130, 140 years removed from Newton's theory of gravity. And I say I don't know the answer to this. I realize this is more of like of a historical physics type question.
Let's do it.
I'll have to look it up. But what were their thoughts? Because you would pretty much instantly see that the universe cannot be static, which is what messed with Einstein. But also is that the gravity is actually going to pull all of these things away.
Are you looking at this? You're thinking about this though in your current knowledge reference?
I'm thinking of this in terms of Newton. I'm thinking this. I am thinking of this in terms of Newton.
Are they thinking of gravity as like that kind of a force that should pull everything and collapse in on itself?
So Newton said.
Or is it just the thing that makes apples fall down?
No, see, Newton says, is this a hangover conversation?
Yeah, let's put a pin in this one and hang over it because I have thoughts as well. I have the thoughts and opinions.
Okay.
Hold on. Let's do ASMR for people.
I don't know if I want to do that.
I'm so glad I don't have to hear that. Oh, I hear it. Oh, damn it. I hope it's watery.
I made a really big drink on purpose. I wouldn't have to make another, but I may make another if I hangover. This is fun.
Well, you have absence.
I mean, historical astronomy, it hits.
It's
hits
right
all
up
of
my
our. Yeah, I mean,
I love this. Until we get to the history of human spaceflight, which should be another fun one.
Been trying.
We're not there yet.
But that is with Konstantin Tversky at the turn of the century. We'll talk about that in a few moments here. So let's move to the planets. The things that go around the sun.
Planets! Yeah, because, holy shit, we've been focusing on stars and not the planets, and the planets are not...
Are not what?
Nobody knows about all the planets, or they think there's too many planets, or
I mean,
they don't know what
enough planets.
There's two things about the 1800s that I love about planets, and my most favorite is number one on the list, which I guess Brandon's going to hit right now. But this is my favorite story.
Oh, this is my favorite story too about discovery of planets.
Well, of this particular planet.
All right, so let's put this into perspective, and we'll have Mike take it away.
Oh, okay.
So in 1801, we have, let's count them, Mercury. It's not 1801, I take it back. Let's do December 31st, 1799, just so we can be a little more careful here.
Okay. All right.
We have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune, Uranus. Sorry, no, I take it back. Sorry, I take it back. Uranus, just Uranus. Why did I say Neptune first? I got excited.
All right, yes, there you go.
Uranus.
Those are the 7 planets.
So no Neptune, just the Uranus in there.
Yeah, it ends at
Uranus.
Or
Uranus stops.
Let's be historically accurate. And at this time, it didn't have its official name.
King George III.
George's star.
King George III.
Hey,
George's star.
My star.
His star. And even at that time, the names were still in flux depending on what country you're in. So let's call it George's star for 1799.
George's star.
So we're gonna piss everybody else. We're gonna piss off everybody outside of England.
Yeah.
Except Federico. But
isn't that?
But we had people studying the orbits of these planets, and at least one of them thought something is a little bit odd. So, Mike.
Oh, it wasn't just one.
Yeah,
because planet orbits should be stable.
They
it should be predictable and stable, and nothing weird should be going on.
All right, so you discover Uranus. And Uranus is going to slowly march around the sun. As it is moving around the sun, we're going to be able to see it slowly march.
And we should still, for sake of historical accuracy, just call it George's star, please.
George's star.
Or, as George would say, my star.
So, people are looking at my star, Uranus.
Yes.
George's star, whatever. I'm going to call it Uranus because I can't call it anything else.
Well, hold on. When was Uranus officially made the name of Uranus?
Oh.
Or in the Greek pronunciation, Uranus.
My gut says the 20th 30s. That's my gut, but I may be wrong.
Wait, the what?
1820s,
1830s.
Okay, you said 2030s? And I was like,
or
what?
30s.
1820s or 30s.
Okay, 1820s,
Okay.
1830s. All right, so
Maybe wrong, but I think so.
well, by the time we get to this, it is already called Uranus, correct? It doesn't matter. I'm going to call it Uranus.
All right. It's Uranus. We're talking about Uranus, everybody.
Okay, so
Get out.
They're noticing where Uranus is. They mark it down. They come back a couple of nights later, a month later, whatever. They notice where it is in the telescope. They mark it down. And then they compare it to what Newton would say Uranus is located.
And it's
not.
It's not where it should be.
It's not where it should be.
No.
Wait. My God. They got caught in my headphones.
It's okay.
And so the thought is something's pulling on it because Newton's gravity, right?
Uh-huh.
So it's pulling on it. It's pulling it out of its orbit.
Dragging it a little bit. It's not where it should be.
Yeah.
There's got to be some external influence that's happening.
So I believe he was French. Urbain Le Verrier.
You believe he was
Yeah,
French?
he's French.
Urban.
With the name
Urban.
of Urbain
Urbain
Le
Le
Verrier.
Verrier.
It sounds like a fancy water.
Could be
I
German.
bet that motherfucker could protest.
Oh, shit. I'm retiring at 62, damn it. Anyway, but he was a mathematician.
Oh.
He's not even an astronomer.
No, he just likes to do math.
Or a physicist
weirdo.
or anything like that.
Just likes to
And
add
so, he's a mathematician. So he actually used Newton's equations and actually calculates where this unseen planet would be that is actually pulling on Uranus or Georgia star, whatever you want to call it. My planet.
We'll say Uranus.
My planet. Is actually pulling on it. And he lets a buddy, Johann Gale, know.
Hey, Johann.
He sends them a text.
I'm doing some math.
I'm doing some.
Bro, this
And-
shit's not adding up.
And
I need
can
you to-
read?
But
I need
Can
you
you
to
read?
look at some
Go ahead.
shit.
And then just make sure you read what I have in the notes there when you get to it.
so Gale, he actually is an astronomer. He's at an observatory.
I think it would be like Galilei.
Yeah, I think actually he was at the Berlin Observatory.
Okay.
And it's not in the notes, but I believe he was at the Berlin Observatory. He's somewhere in Germany.
All right.
He sends them a text, sends them an email with
Send
a
some
paper,
text.
a little
Just,
PDF, sends it off.
Yo, my man.
Yeah, check my math. And he actually tells Gale where that planet should be.
Hey, this should be here.
Love that.
I need you to look through your scope.
You look this up. And Gale's
See
like,
if it's there.
dude, I ain't got nothing else going on tonight. So
Sure.
Look, this-
I'll go find your fucking
This
thing.
No,
chick canceled
my
on me.
They went down to the bar. They left me here at the observatory. I ain't got nothing to do. I'm just gonna look. I'm gonna look where
Nothing's on Netflix
this
tonight.
French man told me to look.
Yeah.
And
Always do what the French tell you to do.
You gotta believe the
They
French.
got the best fries.
And we don't get along, us and the French, but I'm gonna look where he told me to look. And guess what? He went out. He opened up the observatory. He opened up the telescope, put his little eyepiece in, and what did he do, Brandon? He found that fucker.
He went and found that fucker.
Yep.
Said,
found it.
hey,
Yep. And
It's
so
right here.
so actually
got it.
he found it within one night.
I'm sorry, I don't know how you even, but okay.
Within
I
a
found
night.
that fucker. Yeah. I'm assuming is what he said.
Oh,
Well, he's not
that's
the
very
French-
French.
he's not
No,
the
Oh,
French
sorry.
one.
Sorry. Yes, I apologize. That was
He's not
Urban who
French.
said that.
Johann's
Yeah.
not French.
No, he's German.
He's German.
Yeah, so it was more angry
I-
sounding.
It's very angry sounding, but with love.
Pizza.
Yeah, and so it is the craziest story, but it's a great story.
It's countries, nationalities coming together to work together to solve a problem. You have math
honestly,
coming with.
I think it's countries coming together. I
Yeah.
think it's nerds coming
It's
together.
It's nerds coming together.
It's like nerds. Like this
It's
is cool
nerds
stuff, man.
uniting.
This is
Across
across
borders.
disciplines.
Yeah.
Nerds don't prescribe to borders.
No,
I
this
will
is-
also say, between Mike and Liz, I think this was the most drunk history we have ever done. Like, I could visualize this happening.
We finally reached what we were trying to achieve with Cosmos
Drunk
and
Astronomy.
Cosmos.
The original name for Cosmos was Drunk Astronomy. And so
We got-
That was like
finally
we
did
did
it.
it.
2014,
Bro.
2015.
we did
I found it.
Yeah, and so he found it within the night.
So Neptune is the only planet to be discovered with math versus
math.
observational astronomy.
Confirmed with observations in our solar system,
confirmed with observations, but really discovered with the math because Uranus was not where it was supposed to be, and it should be where it was supposed to be if there was no other gravitational influence on it.
Wait! It would be where it was supposed to be. Love it. This is just an episode of tattoos.
Okay, I know, right? So let's fast forward a century. I know we don't want to do this, but let's fast forward a century.
All right. We're doodling.
We're looking at Pluto.
Oh.
Ooh.
Pluto's orbit is not where it's supposed to be.
Oh, fuck.
My God.
The jury is still out on that.
Take your glasses off.
The jury is still out. But there could be a Planet X. And so we will go back to 9 planets. Interestingly enough. Okay,
well,
no.
We can't say back to 9 planets.
Oh, okay.
In the 1890s. Here.
No, that is
reel us back into the episode here.
That is
Let's
true.
reel this back into the episode.
Reel us back in.
We don't have 9 planets in the 1800s.
No, we have 190 billion.
We have many more.
Okay, yes.
So we
let's
just
talk
talked
about how many planets there were. A plethora of planets in the 1800s.
A plethora of planets. So as we had previously discussed, we had, of course, a plethora of planets. I'm finding something on my phone here. There we go. So in 1856, according to the good Irishman, what was it? Lardner. Anyway,
say it with confidence, man.
I was looking for his first name. His first name's even better. Ready for this?
Yes.
Dionysius Lardner.
Dionysius?
Formerly professor of natural philosophy and astronomy in University College London.
Dionysius is an Irishman?
That's the name of our kid. It's going to be Dionysius Davison George.
What, the god of wine and basically party?
And then you just call him Dio?
And his middle name is Ronnie James.
What are we doing with this podcast?
Dio, Ronnie James, George Davison.
All right, let's come back here. So according to Dionysius Gardner here, in 1856, he says this as it's a matter of fact, there are 33 known planets in the solar system.
33.
Of course, we have Mercury,
mnemonic.
Venus, Earth, Mars.
Okay.
And then between, of course, Mars, Jupiter, and outside of Uranus as well, we have Ceres, Pallas, Juno, Vesta, Astra, Heb, Iris, Flora, Metis, Hygienia, Parthenope, Victoria, Eugenia, Irene, Pneumonia, Psyche, Thetis, Mepone, Fortuna, Macelia, Lututia, Calliope, Thelia, Themis,
what accent are you doing?
Ocia, Persephone, Euterpe, Bellona. No, it wasn't Persephone. Amphitrite, Urania, Eurocene, Pomona.
I'm sorry.
Polyemia, Leucothian.
He's just making
what
names
are these? Are these moons?
Yeah, those are. What did they end up being?
No. So those were, as described in 1876, 20 years later, as small planets, which dwarf planets, asteroids.
These are just asteroids.
So you'll notice in the start of this section, I specifically said not 1801. I backtracked. I said 1799.
Okay.
Because I believe it was January 1st, 1800. We discovered the planet Ceres.
Okay.
However, it was described, and then William Herschel, my boy, took a look at it and found it was only a couple 100 miles wide. And so he said, no, it's not a planet. He called it. This was new at the time. He created the word asteroid.
Wait, Herschel created asteroid?
Welcome to my boy.
Old chap.
Old chap.
Wow. I mean, wow. Okay. But what's funny, though, is that we don't actually get a definition for a planet until 2006.
And even that definition is shitty. It's a shitty definition. No, it's a shitty definition.
I don't know.
Clearing its orbits? No, its orbits?
Spherical and clearing its orbit?
I mean, hell, the Earth's barely spherical and has not cleared its orbit.
Okay, hold on.
That's the hangover topic.
Hangover topic.
Okay.
Oh boy. Okay.
Oh man,
Right,
guys,
now,
I hope you don't have Easter dinner plans.
We should never have higher
planets. Now let's move over to 1876, where we have the definition. The categories are 8 large planets, of course, Mercury through Neptune at this point, and 97 small planets.
97 small planets.
And they call them large planets and small planets. And of course, now we have 18.
Which is what the fuck we do today.
Which is what dwarf planets are. They're small planets. They're just not
Yeah.
big enough to clear their orbits and become spherical. Well, some are spherical.
And I like the 18 moons as well. That makes me happy.
Yeah. Okay. So Earth was 1. They've got the 2. Asoph Hall's got the 2 from Mars at this point, so that's 3.
Phobos and Deimos.
Yeah, and so Jupiter and Saturn and Uranus and Neptune are breaking up 15 moons at this point. Hey,
Oh wow!
you know, when I graduated from high school,
and I think Uranus at this point only had 1 known moon.
Oh, it has 27 moons now. Everybody, for context.
yeah, when I graduated from high school, Jupiter had 18.
And it has how many moons does Jupiter have now?
It's
Had like 91.
Yeah, it has more than Saturn now.
Has more than Saturn.
Come on,
Yeah,
Saturn, what
it
are you
jumped
doing?
over
It is
Saturn.
the biggest planet. I mean, it makes sense for it to have the most moons.
Yeah,
but-
but I don't know why, but I really want Saturn to have
Saturn.
more
It
moons.
has
I want
the
Saturn to win.
rings. Saturn already has so much going
Thank
for
you.
it.
All right, let's bring this back here because we are now we get a lot of time here. All right, so we have 97 small planets, 8 large, 18 moons. So one of my absolute favorite things about any old astronomy book written before 1950, 1955, I'll even say,
Oh, okay.
is the idea of where is life in the solar system.
How
It is my favorite topic.
were people thinking a lot about life in the solar system at this in the 1800s or
Well, if Earth is a planet and we have planets out there, and these planets, according to their observations, have atmospheres and clouds and oceans and polar ice
Okay.
caps, they're
Then
thinking
aliens.
life. As a
Okay.
matter of fact, as late as the 1920s, some astronomers, one astronomer who got published somehow, thought that the oceans on the moon, the seas, Sea of Tranquility,
The mare, yeah.
they thought they were migrating insects.
Oh God! For God's sake!
Fabulous. But in
I
any
mean,
case,
now
was
it's
not
just tardigrades, but
hangover.
okay.
Well, it wasn't too long ago, quote unquote, that they just thought that Venus was a tropical planet.
Well,
Yes, and that's exactly right. They
Tropical
saw that
hellscape.
Venus had this
Yep.
nice thick atmosphere with clouds on it,
Mm-hmm.
and because it's closer to the sun, they had the reason it's probably a tropical planet.
they didn't
So-
factor in the sulfuric acid rain.
No, so up until the
They
50s,
didn't know it at the time. No.
up until like the mid 50s, they thought Venus would be the place to look for life on the solar system because of this tropical
The
atmosphere.
1950s.
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 But that's not far away.
We know nothing. I'm gonna throw it out there right now that even with all we know now in the year 2023, the
distant
future that the Jetsons have with flying cars that are not a thing yet, that we basically really probably most likely know absolutely nothing.
No,
we know
I agree.
1%
I
of
agree.
the actual truth of the universe.
I completely agree with that statement.
and I'm being generous.
But what I like about 2023 versus 1876 or 1899 is that we know enough to understand the tiniest amount, but to also understand that we don't know anything.
Okay, that's true. That we know enough to say that we don't know. And I think that is actually really good with physicists and astronomers now, where we don't say the asinine comment that we are pretty
know
much at the end of
everything.
all things. Take a drink.
Yeah.
Here.
I'm gonna hit this.
Hit it, Liz.
It's not. I think my iPad's dead.
Okay, anyway, everybody
My
take a
iPad's
drink.
too dead. Take a drink, everybody.
Here at the end of all things, physicists and astronomers in the 1800s were like, we're at the end. We know everything. Now we become biology and we're just classifying things. Whereas in 2023, you actually do have... Oh, it's so late now.
I know.
Here in 2023, you do have like physicists and astronomers who say that A, we don't know, and B, there's nothing wrong with saying that statement. Because
That
there's
we
not.
Don't know.
I actually think it's better to say that we don't know than it is to say that we know.
And
to assume, making an ass out of you and me, that we know.
I'm gonna take us home. So as we would say, as we are understanding the universe more and more, we're understanding it less and less, which is absolutely correct. Mm-hmm. But as we are searching for life in the 1850s or today, we can still appreciate the fact that we ourselves are simply a way of the universe to slowly know itself.
Oh, well done. Let's take a drink for that.
All right.
I'll take it, and then I'm going to wrap us up.
Okay. Oh.
Got a full clink there. All right, so I'm going to wrap us up in the fashion that I like to do. So talking about life in the 1870s, the inner solar system could be teeming with life. At that time, they believed Mercury had a thick atmosphere, which is weird.
It does
They had thought, and it's true, that Venus has an extraordinarily thick atmosphere.
It does.
In the books, they mention how Mars has oceans, and we see them recede over time.
It doesn't.
It has ice caps.
It does.
And we see those seasonally recede.
Yeah.
And they know that they have clouds and weather as well. So, of course, there must be life on Mars.
Oh, okay.
Now, looking beyond Mars, the issue with the outer planets is, of course, they are larger masses, so they have greater gravity. So how could biological creatures contain enough strength in their bodies to survive on these planets?
Star Wars.
What?
That's what you think in Bespin?
Yes.
Okay.
Oh, do we have to take a drink for that?
Well, yeah.
So.
All right.
Damn it.
We gotta. Oh, I forgot this isn't. Fuck. God damn it.
Fuck. Goddamn it.
I need to remember to charge.
Welcome
my
to the
iPad.
last few minutes of Cosmos.
Well, we need a second monitor.
No, I need
All right,
to
so
recharge the iPad.
the knowledge of the 19th century was not gas giants. They did not know that they were gas giants. They just figured that they were massive planets, and the gravity would be too intense for life as we know it. So they just wrote life off. Maybe one of the moons they talked about, which is really cool.
And they can't,
but not the planets themselves.
And they don't have observations, real detailed observations of the moons of Jupiter or Saturn to really.
No, but Europa has always been one of the favorites early on.
Has it? Okay.
It has been.
Okay. It's still a favorite today, everybody.
So that was 1876. If we look forward to the 1890s, again, we get so close to just exploding the knowledge. We have absorption lines. Using the absorption lines, we understand stars have redshift to them and are moving away. And we look at nebulae at the time, and they are moving away, but those are actually galaxies moving away as well. Annie Jump Cannon, Annie, discovers her first star on her way to superstardom.
I can't help but think Elden Ring with that.
That's Brandon's character in Elden Ring.
My Elden Ring character is named Annie Jump Cannon.
Well, one of them, anyway.
The best one.
And then we have Konstantin Tversky, the father of Soviet rocketry, who's fully alive at this time. At 1895, he's beginning to surmise sending rockets to space.
What, instead of halfway alive?
Fully alive.
Fully alive. Instead of
fully alive.
Fully
alive. Wait, by fully alive, he's not like 4 years old.
Okay.
Dude's
Okay,
like in his 30s.
All right.
Okay.
He knows what he's talking about at this point.
He's fully an adult.
Fully an adult.
Okay.
And he's already thinking about sending rockets to space, which Robert Garland will join him shortly. And then, of course, 1903, what happens? 1903, is that the miracle year?
1903.
1903, we get the miracle year, and everything changes.
Mr. Planck, everything changes.
So at the start of the century, there are 7 planets. These nebulae are groups of stars.
A lot happens in a whole century.
Yeah, who could have thunk? So at the start of it, 7 planets, groups of stars. We have the universe known as the Milky Way, and maybe things lay outside of the universe.
Maybe.
Probably not, though, at the beginning.
They just
but
weege
at
out
the
there.
end, we have the rumblings of the great debate saying whether the Milky Way is the universe or if the Milky Way is just one cog, one brick in the wall, if you will, of everything else.
Well done. Pink Floyd reference. Oh, wow. Okay, anyway, continue.
And then we have the idea of absorption lines, emission lines at that point, discovering what elements are on stars, to Max Planck just like a decade later. Planck, thank you.
Not even a decade later.
It really goes from observational science to theoretical science. And
really quick. I mean, it was really quick.
That's exciting.
If we did this episode on the 20th century, it would take 5 years.
Oh, that really is true. Especially if we...
It would take this entire podcast length we've been doing.
Honestly, I feel like...
based on 20th century, 21st century.
Human history is basically like, we know nothing for the longest time, and then all of a sudden...
And then we have inklings, we have thoughts, we have ideas.
It's like, like little percolations, and all of a sudden it's like, BAM! We're able to, like, figure some shit out.
I mean, okay, so... When Liz and I went to a liquor store yesterday to buy the absinthe, and the guy was like, "So you're going to rewrite modernism now," and really and truly, oh God, I had it formulated in my head, and now I've lost it. But I mean, in the 1800s. It's like the 1800s are on absence compared to like the 1600s and 1700s. And it basically rewrote our understanding of the universe. And then the 20th century came along.
Wait, I got this. If the 19th century was one small step, the 20th century was one giant leap.
Oh. All right, take a drink to that. Cheers.
And with that, ladies and gentlemen, thank you for joining Cosmos with Cosmos. This was a delightful, as Teddy Roosevelt would say, episode. Again, follow us on all things. Watch the shot. Listen to the shot. It's great. For those of you here with us on YouTube, or if you're not at this point, doesn't matter, join us, The Hangover, where we'll talk about what is a planet. We'll talk about science in the 20th century. It's going to be great. It's going to be a good time. And I'm going to make a second drink. And I thought this would last me 2 hours.
Oh,
Cheers, everybody.
Bye. For those of you with us here on YouTube, stick around. Thank you, Katie. We will be right back.
Oh, this was like my peak nerd episode.
We're not even muted yet, so that's a
great
line
out. My iPad is so low battery that it won't do anything. So I have to manually do everything. No. Well,
I was really concerned that my outline wouldn't be more than 20 minutes.
Look,
we're still live, dude.
We're still live.
Well, Jesus Christ.
Hold on. I gotta.
Jesus Christ coming out of a rabbit egg.
All right. Now we're good.
That really was a good episode.
That was fun.
Where'd Brandon go? I don't see Brandon.
Well, you'll see him. He sees us.
But we don't see him.
We can imagine him.
All right, go make your drink, buddy.
You should not still be able to hear us. Do you still hear us right now? If you still hear us, say yes.
Oh, is it?
It should. No. No. It shouldn't. It should not be. I think my iPad just died. Do you still hear us now? Because according to OBS, we're muted.
Oh, your mom hears us.
The music came on for a second.
You know what?
Oh, wait. Hold on. I knew the problem. There we go. Hold on. And now the ISS music should still be on. If you hear me talking right now, I don't know what's happening.
All right, we cannot give at least some of these people a hard time because we still stay here.
Oh, they still hear us. Okay, hold on, everybody. This is why it's helpful to have two monitors. We found.
back into use.
Okay, are we
Here's
here?
what happened. I needed some bread because I didn't eat lunch. Also, my iPad died. It had 30%, which I thought would be enough to get us through, but apparently not. So
I can talk for a while.
I have to manually do the audio and shit, so that's why there was a bit of a kerfuffle between break and now. So, but I'm still going to continue to eat
Katie,
bits and pieces
Liz
of my
is drunk.
bread.
Everything makes sense now.
You know what, though? Her
Yeah.
husband is feeling it as well.
Oh, my.
So it's a dual drunkard situation.
And
Which is...
there B has lots of drink left.
Hey!
All right, I'm going to see if this little bit gets me through the hangover. I doubt it will, but let's see what
I
happens.
feel like I'm back at the Green Dragon after a long day's work.
Shit.
Though you've never done a long day's
How
work.
difficult it is now
So clearly, when we are together doing Cosmos and Cosmos episodes, we can contain ourselves. But when we go back to remote, we go back to black hole episodes and science fiction episodes, and truly meet the standard of what this podcast is about: is drunk people talking about astronomy.
Mm-hmm.
Yeah, that was the original idea behind this. But it the little giggle just put it over the top. Oh, Pippin.
All right. I got some bread in me. Drinking more.
Well,
This is a
you're in
great
charge.
hangover.
You're still in charge.
So what we got here, so we're going to do a couple things. The first thing that we're going to do is talk about where my next tattoo is going to go.
Oh, yes.
Yes. So as we had discussed in the episode, we have the William Caroline Herschel map of the universe, which looks like a bug splatter, as Jack said. And for years, I wanted that tattoo. But instead of getting it, I got this tattoo, which is a pulsar map of the universe, because it just fits so well. Now, ideally, I could put Herschel's map on this forearm so I could have two maps of the universe based off of 200 years of knowledge.
Oh.
However,
Okay.
I have a mental block. I cannot put tattoos on the right side of me.
What?
But
I can't.
But to be
Why?
honest, I get
Why?
that. I get it. I get
Why?
it. I can't put a tattoo on my back because I can't see it. So I sort of get what he's saying.
As someone who has 3 tattoos along the back of their neck, their back, and their lower back.
See, but that's different. That's symmetrical. The spine and the lower back is still symmetrical throughout the body.
Yeah, I forget
And
they're there until I take a shower, and then I get out of the shower, and I'm like, oh, right.
Yeah, but I'm gonna see the tattoos on my body here on the forearms.
Yeah, so then...
in lieu of my forearm, I have 2 different options, which have pros and cons to both of them.
Okay.
So of course I have the tattoo on my forearm here of the new map of the solar of the galaxy, the universe, so galaxy. And then I can put it on my biceps here, the Herschel. So it's like a transition of time, which would be very cool.
Oh, that's actually okay.
But I wanted another tattoo here, which is the last lines of Dante's Inferno in Italian.
No.
So it's gonna be a trade-off.
I think the map of the universe, the Herschel map of the universe, and then you get Dante's Inferno elsewhere.
But do you know what the last lines of Dante's Inferno are?
I don't remember, but you did text it to us. But I don't remember.
I did because I wanted to get it when I was in Amsterdam. So keep in mind, last lines of Dante's Inferno is after Virgil, the narrator, they go literally through all the layers of hell, and they see all the torture and torments and the suffering. The last line is, "And thenceforth we left to see the stars again." Love it.
Oh, turtles all the way down.
Your leg.
Oh, God, that's a fucking good tattoo.
Oh,
That is a good one.
That is a good tattoo.
God, that's
Holy
a good
shit.
God damn it, Adam.
Oh, fucking, it's on the leg, too.
I feel like the line for Dante's Inferno would actually be a good, like, back of the shoulder blade kind of,
Oh, and maybe have it go down the other side. I could see that.
You know, like, that could work.
Because I've been attached to the Herschel map for years at this point, maybe a decade at this point. I'm kind of with Katie there.
Katie likes, both maps of one arm. That's a good and that's a good story when you're explaining that tattoos for people who ask.
Okay. First of all, two things. Brandon, I think you just need to jump in and get it on the other side of the body. It's on the.
Nope.
You can't.
Okay. All right.
You can't
No.
do it.
Okay. I can respect that. Second of all, Jack, they will shave your arm for a minute.
Yeah, but the hair grows back.
The hair grows back.
That's his thing. He's saying he's got too much hair for it to be
visible.
visible.
To show through.
Do you have Robin Williams-esque arm hair,
to show
Jack?
through. Oh, I get that.
Yeah, because that's a problem. If you got that level of.
But maybe if you make the lines a little thicker, a little darker. It'll pop through the hair. It depends
on what level of Robin Williams you got. 10 is max Robin Williams.
All right, so 0 is Bicentennial Man. 10 is what do you call it, Jumanji Man.
Yeah.
My God. And now I think of it.
Oh, too soon.
Robin is his fur brother. Well, then you're yeah.
Well,
arm tattoos aren't gonna work for you then.
No,
But face tattoos though may do the job.
We're gonna Mike Tyson it,
right?
Oh, that is a tattoo. All right, so I want to get a tattoo of our Cosmos right here. Our logo.
Oh, you do?
I do, and it's gonna hurt like shit, but I do want to put it there. But the guy who did my most recent tattoos, the CSM and the LEM, he had facial tattoos, and I really wanted to go, dude, how much did that hurt? There's no way I am ever getting a facial tattoo.
Neck and above tattoo.
Huh?
So
you can do back of the neck, but this side of the neck, I would prefer you did not.
This is my neck. This is where I'm putting LIGO right here.
LIGO.
Whoa! Wait! The LIGO tattoo? Like wait.
No, this is gonna be the Cosmos tattoo right here on my.
Oh, I was thinking like LIGO. That would actually be really fucking cool.
Well, yeah.
Look, you have an Adam's apple. I do not.
Speaking of LIGO, I did want to. I was thinking about this the other day. I want to get the tattoo of the the black holes merging for the first black hole that LIGO got.
Yes.
Basically converting that into basically quote unquote sound waves. I want to put that. I just can't decide where to put it. But you see, this picture right here is going to go right here.
Oh, okay.
Fun. I like that.
So that's going to go on my bicep, but I do want to get the gravitational waves. Oh, that's a good place where it starts off really, really low, small, but then really boom.
My mom says, guys, there are regular tattoos and there are prison tattoos.
Okay.
And I will say this
hold on. I got to tell this story.
You ain't right.
Go ahead, Brandon. I gotta tell the story though after you.
I just made my shitty joke. Continue.
Okay, so this is my most recent tattoos, and I got it a week ago, and I sent a picture to my sister. Oh, it's good. I sent a picture to my sister, who was getting tattoos, and apparently she showed it to my parents. Now, my parents are diehard Catholics. Today's a big day for them.
Right, it's that day.
It's Easter.
Yeah, and
Jesus comes out of the cave.
They do not believe in tattoos. It's just a different generation, and whatever works for you. But my mom was like, "I'm gonna get a teardrop on my cheek because." Me crying for my kids getting tattoos because my sister Ricky has gotten some tattoos as well, and I was like, "Mom, that's just that has a different meaning than you think, Mom." so my mom might get a prison tattoo right there on her cheek.
Glenda's got some bodies we don't know.
Yeah. Oh my gosh, it was. I told Ricky because this was Ricky told me, she's my sister. She told me that our mom was like, no, she said she's gonna get that teardrop, and I'm like, you need to tell her that is a different meaning, and that she doesn't need to. She said she was gonna get her nose pierced and a teardrop.
Oh, absolutely.
Because Ricky has her nose pierced, and I said, I will friggin' pay for that. I will pay for it. I will even go with her to the tattoo shop. I will pay for
folks. It. So this is a moment that we can have off the podcast. And I want to bring us back and have a hangover conversation.
Mm-hmm.
Planets.
I
think
what a
the definition of planets is terrible.
Oh, okay. I, on the surface, will agree with you.
Okay. I will disagree with you.
Excellent. So we got ourselves a regular debate here. I'm going to take a drink so I'm nice and tipsy when I make my points.
I'm not going to take a drink because I've had too much and I'm waiting for the bread to kick in that I've been eating.
Get that bread. All right. So
I'm out of bread.
So Liz, what is the IAU's definition of a planet?
All right. The IAU.
Wait. Which, by the way, really quick before you answer it, I will preamble by saying, when the IAU made this vote of a definition,
who's the IAU?
Less than 30%.
International Astronomical Union.
Yeah, well, he didn't say it.
Oh. Okay.
IAU. What did I say?
He said IAU. He didn't say what it was.
International Astronomical Union.
Thank you. Yes. When they made that vote in 2008, 2007-ish.
2006.
2006-ish.
August
like I said.
2006. End of August.
Like I said, ish. Less than 30% of the voting members were in attendance, and none of the planetary members were in attendance making that vote.
Okay.
So with that in mind,
all right.
Continue.
Definition is 1. A planet must be spherical. That means it has enough gravity to just naturally make it into a sphere. Because that's the least.
I'm on board.
That's the least energetic.
That's not the first definition.
Well, I'm doing it in my order.
All right, this is Liz's order.
This is Liz's order. That is the least energetic state of an object is to be spherical. So it has to be spherical. 2. A planet must be large enough. Wait, how many rules are there?
There's 3 rules. There's only 3 rules.
There are 4 lights.
The first rule is...
It must be spherical.
No, the first rule is it must go around the sun.
Oh, okay. That's the one I was forgetting. It must directly orbit the sun. Yes. That means it doesn't orbit another body that orbits the sun directly. It must, in fact, itself directly orbit the sun. 2.
That's a good way of saying it.
Thank you.
You just... succinctly define the definition of a quote-unquote planet versus a moon.
Thank you.
Very good.
Thank you. 2, it must be spherical. It must have enough gravity that it naturally turns into a sphere, which is the least energetic state of an object. 3, it must have cleared its orbit, meaning during the formation of our solar system, it was large enough to clear out all the
smaller bodies.
Extraneous the smaller bodies, gas and dust, so that it has a clear orbit around the sun, meaning it's not surrounded by a bunch of other shit.
Yeah, and I think that's where me and Brandon actually disagree.
Oh.
But I think having not heard Brandon's disagreement, I actually might end up agreeing with him, but we'll see where he goes.
Okay, now starting off, I agree with this definition of a planet because it makes some clear definitions that then distinguish between, say, asteroids and comets.
Yep.
Pluto, for example, which is what the whole thing is about. Of what
Ceres, Vesta, absolutely.
Discovering of Eris with Pluto. That's what the whole thing started with, making. Oh, maybe we should define what a planet is. Pluto is spherical. Pluto orbits the sun directly. However, Pluto is surrounded by billions of other objects, namely comets that in its same orbit around the sun.
That's the key thing right there.
Believe if Liz is open to having her mind change, which I am. I know Mike is. If Liz is open to having her opinion swayed, I think we can have some major progress here in this session.
Oh, okay. Well, all right. I guess what we need to do before we get into Brandon's issue with it is to get into my issue with it.
All right.
First of all, I think this definition is spot on. I do think that
you like the definition.
Wait. My headphone has gone. I can't hear what you're saying.
What did you do?
Oh,
I'm back.
Did you see? Okay. All right. I didn't know if it was a bit or what.
No.
All right. No, I agree that prior to August of 2006, we needed a definition of a planet.
Yeah, we didn't really have one. There was no planet. It was an object that orbits the sun.
100% agree.
Something that orbits the sun is a planet.
Anything that went around the sun and then it became this arbitrary thing because it really became the discovery of Eris. And it was like, okay, Eris is larger than Pluto. It goes around the sun, so it's a planet. We now have 10 planets. But anyway, so my issue with the definition, and what you said for the definition is spot on. It's 100% what it is. My issue with the definition is number 3, which is that it has the clearest orbit. My issue is that there is no numerical value as how you define clearing your orbit. And so if you look at the Earth, I think Brandon might bring this up. If you look at the Earth basically has not cleared its orbit. But if you add up all of the mass of all of the objects that are roughly in the same orbit as the Earth, 93 million miles away from the sun, if you add up the mass of all those objects, it is insignificant compared to the Earth. If you look at Pluto, if you go out to Pluto is what, 4 billion miles away from the sun, roughly, give or take, because it actually does cross Neptune's orbit.
Liz is having kitten hiccups.
What's that?
Liz is having kitten hiccups.
Yeah. So if you add up the mass of everything else that shares Pluto's orbit, it is actually greater than Pluto. So
now, may I jump in?
I'm sorry. Are you proving my point?
By all means.
Are you proving my point?
By all means.
We've proven my point.
No, exactly.
Let us.
I agree with you. I agree with the IAU definition. My only issue is that there is no. You are not assigning a value.
No. However, let me.
Okay.
If we swap places, if you put Pluto where the Earth is, the area of Pluto's orbit is still not greater than Pluto. So in that case, Pluto, if it were in Earth's position, would be a planet.
Right. But the problem is
not the other stuff surrounding Pluto.
I think the problem is that you're looking at the evolution of the solar system as
you have walked into my trap. Continue.
I think the problem is that you're looking at the evolution of the universe as it is today. If Pluto were 93 million miles away from the sun, the inner solar system would have evolved very differently than it does now.
Would it have?
Yes, it would. Yes, it would.
Wait,
yes, it would.
There is.
Yes, it would, because Pluto does not have the gravity that the Earth does, and so it's not going to affect its local region. Like
I will posit to you, sir, that the workings of the inner solar system is less affected from the Earth and more affected by the gas giant of Jupiter.
No, I agree with that. However, as the Earth goes around the sun, it does affect things that are 93 million miles away from the sun.
So, if I may, so would you not agree that the planets classically known as
Sherlock
Mercury,
Holmes thing,
that the planets classically known as Mercury would not have its own orbit more affected by the sun than its own body?
Right.
So in that case, would you not say that the Earth?
So this is where.
On
hold on, Brandon. This is where you and I actually agree. Is that because all they did was just say this very generic statement.
There we go.
That it has to clear its orbit.
100%.
That, by definition, is not scientific.
Yes.
They did not turn it into a scientific definition.
Oh, okay. But even though the disparity between...
Oh, that was beautiful. All right, go ahead.
How many things are in Pluto's orbit around the sun comparatively to the rest of the planets? Earth and Jupiter have Trojan asteroids and all these asteroids.
So I think
it. I mean, it's
mass around its individual orbit.
I mean, if it's clearing its orbit means like, it's got a few things hanging out with it versus a lot of things hanging out with it. Pluto has a lot of things hanging out with it.
Right, and so the question then becomes.
Damn it.
So, yeah, you're not a fish.
So really quick, I went to do a Planetarium show, and I had the hiccups. And I tried as hard as I could not to have the hiccups, but I gave the show anyway. But every time I hiccuped and I explained what was going on, the audience, which was like a good 80 people, they laughed at me every time.
Yeah, but
which is all they could do.
Yeah, I've had
the
hiccups during a Planetarium show before, and I was not drunk.
It is funny.
I was not drunk either, mind you. I was only drunk for one show my Planetarium career.
Oh, hold on, what?
I told you about this.
All right. Oh, but
I told you about this.
There was one show where I was extremely hungover, but anyway.
Well, me too, but Liz knows that one.
Yeah. So the issue though is really that they just made 3 generic statements, two of which I wholeheartedly agree with. Gotta go around the sun. You have to be spherical because you don't need to say anything else beyond that, because that just statement alone has physics behind it. But the third statement, as I flip everybody off, the third statement of you have to clear your orbit is that there's no definition of that in the definition of a planet.
And I completely agree with that. And I will say again that this vote was made when less than 30% of the IAU was actually there.
Why?
Right, but the thing is okay, first of all...
Politics, Liz.
Oh, God.
It's like gerrymandering of the solar system.
No, first of all, it was still within the... Don't Steve Russo this. He's a planetarium person.
That's for those Domel members.
So it was still part of the IAU meeting. Those 70% decided to leave without voting. And it's not like those 70% were fully straight on planetary scientists.
I agree.
And also it's not like this is the last IAU meeting that has occurred. There have been other meetings. So where IAU has failed is they did put this at the end, and they did allow members to leave without voting. However, there's no just scientific physical definition of what it means to clear an orbit.
And I will also, I agree, 100% agree. And I'll also speak to the fact that science, its definition, its progress, is subjugated to the whims of whether it's an individual people or a group of people.
Right. Okay.
But also, Pluto's tilted 5 degrees off the plane of our solar system.
Yes.
Right. It is tilted. Yeah.
It's tilted off the plane of our solar system, meaning it didn't form exactly at the same time of our solar system.
But
which
you're
is another negative against the planet.
You're subscribing to old definitions of planetary. So why not go back to 1870 definition of what a planet is?
Because, all right, so I really think that the IAU could have avoided all of this by just saying that this potential planet, has to have the remaining mass in this planet's orbit, and you need to even define what that means.
Yes.
Is it, if you're 93 million miles away from the sun, is it plus or minus 5 million miles? What does that mean? it has, if you take the mass of all the objects that are 93 million miles away from the sun, the Earth's orbit, then that mass has to, not including any moons.
But that has issues too.
No, it does not. The moon goes around.
Mike has a bulletproof plan.
The moon goes around the planet. The moon is going around the planet. The moon is not going around the sun, so it does not fall into the definition.
But are we saying exactly? Wait. You'll appreciate this. Are we talking exactly 93 million miles? Or are we talking about 93 miles plus or minus 6,000 miles?
No, I just said that.
1 million miles.
No, I did just say that, right? That was my first issue.
We are far too drunk.
No, my first issue with it is that you say that you clear the orbit and you haven't defined plus or minus what that orbit is.
Okay, yes.
Is it like? And I think I said like 5 or 6 million.
That has a huge impact. Of course, the Earth is going to be.
It does, and so
because the Earth is massive.
So why are you yawning? This is a debate.
Alcohol.
This is solid. This is the 21st century great debate, Liz.
Look, I'm trying to hold my breath and
we are in a
couple
situation.
So let's just, if the IAQ had said that that a potential planet, however distance from the sun, plus or minus 10%, let's say 10%, has to clear its orbit. Plus or minus 10%. Well, it has to be 10% or less.
Wait. And then let's further clarify. I'm on your side at this moment. Let's further clarify that 10% cannot include a moon, which will orbit the barycenter of the individual planets.
Right. No, I get that.
That will make an impact.
By the way, the barycenter, is the center of mass between the planet and the moon.
How much of this is because we don't want to do a new mnemonic?
20%. Okay, so in America, like 86%.
Okay.
So
yeah.
My only issue though is that they have not put numerical values to the definition of this. I agree. That is why I say this definition is shit. That said,
hell yeah,
I agree with the definition. I think that we need a definition of a planet, and
you hell yeah a little too soon, Brandon.
Mm-hmm.
And I do not believe that Pluto falls into the category of a classical planet that goes around the sun.
Look,
let me ask you this. Let me ask both of you.
Okay.
What is your ideal definition of a planet?
My ideal definition of a planet is...
Is it one to disclude Pluto specifically for that reason?
No, not necessarily. I don't believe in that kind of bullshit. I really don't.
I'm in. I got you. I'm in.
I don't believe in politicizing things. So, but what I do believe in is that you make stuff that can be verified scientifically. So first definition, it goes around the sun, which is the stereotypical planet definition of a planet.
Yep. The Aristotle planet.
Prior to 2006, which then includes like, what was it, 97 friggin' objects at the end of the 1800s.
97 small planets, 8 large planets, and 18 moons.
Okay, so over 100 planets. Second thing is, it does need to be round, because I think that is, because you do get to a certain point in size where gravity forces an object to be round. Mm-hmm. Otherwise, it's easy for something to be potato shaped because it's not big enough. Gravity does not force it to be round. So that is crucial. But the third thing is that if you're going to say it has the clearest orbit,
yes,
which really does seem a little bit arbitrary.
Yes.
You need to then define what it means. And I would say that a planet has to clear its orbit where the remaining mass within its orbit, plus or minus 5%, is distance from the sun, by the way, is less than 1%. 1% or less the mass of the planet, of the the main object. And you don't get that with Pluto. The problem is that the IAU since 2006 hasn't really clarified what that definition means.
No.
Jack says his issue is the rule is very soul centric. It will have to be reevaluated.
Oh, absolutely.
It does because in the original definition, what they said was they were very honest, and they said we're only
solar system
this only is our solar system. We're not even talking about exoplanets right now. In fact, if it goes around another star, we're saying it's a planet, no matter its size or anything. Mm-hmm. The problem is they have not even quantifyingly, yay, thank you, alcohol, defined what a brown dwarf is.
Huge difference.
Yeah, because if Jupiter were bigger, at what point does it become a brown dwarf?
I thought it was like 18 times or something.
18 sounds right, yeah.
Yeah, but I don't.
It was 18 times more massive. It would be able to do nuclear fusion.
But is that okay? But that is a scientific threshold, and you're basing your definition on science with that. But I don't think the IAU, which I don't think that we actually what we said its role is, which is defining what is a planet, what is a moon, what is an asteroid, and that type of thing. They actually define these things for us. I don't think that they have actually scientifically defined what a brown dwarf is.
Agreed. Now, I agree. Now I'm going to take it back and back and back and back.
Oh, I have got me riled up, Brandon.
Oh, no. We're staying in the same subject. But I completely agree that there is no scientific definition between a planet and a brown dwarf, which, if there is an exoplanet, which we have found, bigger than Jupiter, which straddles that line, we don't quite have that definition, which matters only because the general public will want to emphasize the planets in the solar system to study for the children.
Well, we like things to be nice and neat and easy.
Right. We like an orderly discussion.
Mm-hmm. We like my very eager mother.
This is a comet. This is the moon.
Right.
However, I think the bigger issue is. Oh, I'm gonna get into it here. I think the bigger issue is things, planets, people, especially moons, asteroids, do not fit into a single subject. There is not a single planet. There's not a single moon. There's not a single star. There's not a single male. There's not a single female. There is a huge variety of existences out there.
Yeah, we like the binaries.
No, we really do like binaries. All right.
We do.
Okay. All right. I do have. Okay.
I'll stop.
The universe doesn't give a fuck what you think. First of all.
What?
Second of all, Pluto is
fabulous.
Doesn't give a shit because it's
Pluto
not.
is fabulous.
Pluto was fabulous. Excellent. But I'm going to go ahead and say Europa is fabulous, but you don't necessarily need to put Europa in the same category as a planet.
Well,
you can't because it goes around Jupiter.
Next to the very center, as we had discussed, which should be implemented.
So here's.
But wait, really quick, may I?
No, go ahead.
So planets and the moon and the asteroid.
This is our next topic, by the way.
Yes. So planet, moon, asteroid, comet, whatever, should not be delineated as to its level of interests. Its existence in itself is incredibly interesting. It's fascinating.
Right.
Whether it's Pluto, whether it's Titan or Europa or Ceres. I don't care if you're a planet or a speck of dust. It is fascinating in and of itself.
Pluto at the end of the day doesn't care what you think, but Pluto really does show the story of how we and we already touched about this in the first episode. The main episode.
Oh my! This has been a solid episode in itself. Let's make this an episode.
The main episode of the podcast.
No, actually, I wasn't kidding when I said this really should be the next podcast.
This should be an episode right here.
I
Liz,
feel like you've done this before. But...
All right, yeah, Liz, make it happen. All right, first of all, Pluto doesn't care what you think, but Pluto really is a beautiful story of how science works. 1930, Pluto's discovered. February 1930, Pluto's discovered. It goes around the sun. Oh, that's when the stock market crashed.
Oh.
No, I think it was 1930 when it was discovered.
I don't know. I'm here for the ride.
I really think February 1930 is when Pluto was discovered.
Okay.
But anyway, Pluto's discovered. It goes around the sun. They call it a planet. However, between 1930 and 2006, we discovered a lot more about the solar system in which we live. February 18th, 1930, I believe. A year.
Yep.
Okay, cool.
1930.
It was blurry? Okay.
1930.
So we've learned a lot. We've learned a lot about the solar system that we live in because technology has improved.
We basically were like, oh shit, there's more shit out by Pluto.
Yeah, and so we quickly discovered that we needed a definition of what a planet was. But because we've learned more, that affects what our definition is. We really don't even need to go further than the 19th century, because Brandon brought up that in the mid 1800s there were 33 planets. By the end of it, it was 97 minor planets, small planets that they called, which were asteroids. And so we redefined what those objects are because we learned more about the solar system in which we reside. And so I think that as we learn more, we're forced to change our definitions of things. There's nothing wrong with that.
Yes.
I don't give a fuck if you grew up with Pluto as a planet. Your opinion as to whether Pluto is a planet is irrelevant because the science needs to guide us with this. And as we learn more, we should change our definitions of things.
I think that's why I side with the IAU, or calling Pluto a dwarf planet versus a planet, is because I like that, we've learned so much that we can distinguish between these different objects and to put them in different categories, like biology, but not like biology.
But their definition is bullshit.
All right. Okay. From a science...
No, wait.
No.
Let me defend.
Pluto's fucked up.
Let me defend.
That's true.
Mike just gave a resounding defense as to why the IU definition of planet is not correct.
Right.
2 of the 3 is right. 2 and 3 is spot on. I completely agree.
Yeah,
but that third definition needs more merit, needs more definition.
Yeah, but
it needs more meat to it.
Yeah, but also at the same time, I think that the first 2 add enough to be like, it's not quite the same.
No.
It didn't form exactly at the same time. There's some weird shit going on.
I want everybody to be clear. I do not think Pluto should be classified as a planet. So, in this great debate that we're having, I actually side
out Hubble.
I side on the side of Liz here, where Pluto should not be defined as a planet. However, my only issue with this definition is the definition is not scientific, because you do not define what it means to clear an orbit. If you had defined that...
You know what? Why do we need labels?
If you had defined it with actual numbers that can then be... Astronomers can then go to...
How much stuff is surrounding for Pluto versus how much stuff is surrounding the other planets?
Pluto is more than the mass of Pluto.
May I?
With the planets, with the classical planets, it is less.
Brandon is asking if he may. So let's...
May I?
You may.
Okay, go ahead.
You may, Brandon.
All right, let me gather my thoughts here.
This is a beautiful episode because the main episode went long.
I'm ready to pass out.
This is just...
I need to order Chinese food very soon.
Oh God, that sounds amazing. We're having ham, and I have to make
wait. In Oak Ridge, is there Chinese food?
Yes, what?
I have to make sweet potato. I have to make sweet potato souffle.
Is there Chinese food?
We have to make
distance in Oak Ridge.
No,
wait a minute, what'd you say?
Nothing within driving distance of Oak Ridge, but a couple of restaurants that are
when I moved in my location here, I made damn sure there is Chinese food.
There's no Chinese food. We will have to, when you visit us in Oak Ridge, we will have to drive to Chinese food for an hour.
Yeah, we have to drive to Eugene.
But there's a really good English pub.
So everybody
in town with good home.
In 3 to 4 weeks, we're going to be moving to Oak Ridge, Oregon. Look it up. We're going to live up in the hills. We decided to be able to see the Milky Way versus.
That's nice.
Look,
it was an HOA.
To Jack's point is his rule. His issue is the rule is very soul centric and has to be reevaluated for all exoplanet systems. But I would like to posit. I would like to put out there that as we've seen, like our solar system tends to be exempt from the rule of other planetary systems.
Yes.
Like you see a lot of gas giants closer to the sun than they should be compared to our knowledge of our planetary system.
Which I'm going to take over for a second.
No. You're not taking over. So then I would say that our rule, I feel like the rule of planets, if we can define what clearing the orbit means, is a good rule to apply to all exoplanet systems.
Right, but you can't.
Because especially, I would say the key component of the rule of what a planet is, or a definition of what a planet is spherical and orbits their central star directly. Mm-hmm. I think those two are actually the key, because if you have obviously a satellite that's orbiting another body that's not the central star system, then that's not going to be necessarily a planet. That's going to be a satellite of another object.
Right.
So the main key factors are spherical and orbiting the central star system.
Yes.
Right.
Those are the main. I agree.
And you know what? That is how we define planets going around other stars. That's how we define it. Because we don't have the technology to see the little bits
that are surrounding it. Like we have so much surrounding us.
Hold on.
Let's back up.
No, I think we can't say that are surrounding it, because that's not what the definition says. Okay, the definition says that it is in basically the same orbit, which is different from surrounding it.
And Pluto doesn't qualify because it's tilted off the plane of the solar system. Therefore, it's not quite in the same planetary.
No.
But that's not part of the definition. The definition says that it just hasn't cleared its orbit. No, it doesn't say anything about
the tilt of the orbit and the orbit being on the plane of the rest of the. Okay.
Now, I think again, the idea that Pluto is less important is not necessary here. We understand that Pluto is as important as any other planet in the solar system, any other asteroid, comet, whatever. It's a fascinating object.
Yeah, that was never in doubt.
Yep. But
do things break down?
The idea of being a planet elevates it in its importance of the public view, and that's what we care about.
All right,
we want every object to be as important as any other object,
and
it's fascinating and interesting.
It is. I am going to be honest.
Yeah.
The public doesn't matter in this.
You're right.
The public does not matter.
However,
astronomy is not democracy.
Look, at this point, it's just classifications.
I haven't spoken in a very long time.
Oh?
Well, you just spoke, but all right.
It matters to the effect that what we decide is a planet is what the vast majority of people study. And that's what the vast majority of people agree is important.
No.
Whatever is not important, whether it was a Ceres or Vesta,
the vast majority of what people study?
No, that can't be a definition for anything.
Let me say, instead of study, learn.
No.
They learn about the planets. They do not learn about Vesta or Ceres.
Okay, hold on.
They may.
Hold on. Okay,
no.
For me, are we talking about astronomers, or are we talking about the general public?
The general public.
General public
the
are
general
dumbasses.
public is irrelevant.
So I'm saying that is why it matters. If the general public does not care about Pluto, would New Horizons been approved for study?
Yes.
No.
Yes.
100% no.
Yes, because
If
nobody.
the public did not have a
The
groundswell.
general public only cares about
Okay.
Pluto because Pluto.
Okay.
Pluto. They started saying Pluto's not a planet. And everybody
Hold
freaked
on.
out because that's not what I learned in school, and so everybody freaked out about it. Ask my
Mike, what's
dad.
up?
He'll tell
Okay,
you
first
Pluto's
of all,
planet.
okay, hold on. First of all, is there any other celestial body that we call a planet does not meet this at all this criteria?
No.
Criteria.
No, wait.
No, this is actually a question from Podcast
No,
Mom.
I agree. No, as of 1930. Before 1930, Ceres could have been a planet.
Well,
Okay,
yeah, but-
Brandon,
We just had the whole podcast about this.
How much
Brandon.
stuff is Ceres surrounded by? That's
2006, we defined what a planet is. So the actual answer to Podcast Mom's question is there
no.
any other celestial body that we call a planet
Wait.
that does not meet all the criteria?
We were answering
No.
your
Is
question?
no.
no. The answer is no.
No. Okay.
No, I agree.
All right. Let's be honest.
I missed the part where we were answering Podcast Mom's question.
Let's be honest. NASA, at the end of the day, is still a political body.
At the end of the day, yes.
Yes. And so
Unfortunately.
it truly
We can get
is.
more into that.
NASA will try to balance public stuff versus science stuff with probably, I am hoping, a weight on the science stuff. Okay. However, when it comes to Pluto, NASA and NASA's missions to, and really and truly, any other space agency's missions to Pluto is irrelevant. When it comes to defining things, the IAU is not part of NASA. It's not part of the European Space Agency or the Japanese Space Agency or anybody else. And so it is really trying to come up with a definition. And so originally, okay, I don't know.
Is there a dog about to throw up?
I don't know what just happened, but maybe. And so the IAU, its definition is lacking in that it really does not define what that third item is.
Okay.
And I think...
And that is where this debate comes from, is that third definition that's not well defined.
Yeah, and I think we all agree that, two of us anyway, agree that Pluto is defined not as a planet. Should not be a planet.
Yes, I agree. I'm not upset that Pluto's a planet. I would love... So I say planet because, and this is where I get into the nitty-gritty, which I would love for Liz to be here.
No,
Should we wait
back.
for a moment?
She's right here. Hold on.
I'll wait.
She
I'll wait.
is sitting down.
I'll wait.
The headphones are on.
Hi, Liz.
Hi.
So this is where I said I would love for Liz to be here.
Yeah, he literally did say
Okay.
that.
I did.
Sorry.
So
Katie
I don't
had,
care.
Katie had Liz's Kate.
Why are you saying that on national TV?
Leia had Katie's owl.
Okay.
Harry Potter owl.
All
and
right.
I had to go.
No damage was done
No
to
damage
said
was done to the
owl.
owl, Katie.
All right.
Leia?
Leia.
Oh, I
shit.
just lost my thought. Go do it. Okay, let me get my thoughts back together.
They keep getting Hedwig. Go put Hedwig in the closet. The dogs have never gone for Hedwig before.
Although I will say, one of my first times in your place in Ogden, we were doing the show, and we were talking about XYZ, and then Leia walked into view and had my stuffed
dog.
which I had before I was alive.
Yeah, and we were like, oh
in
shit.
her mouth. And Liz jumped up to go save it. So I get it.
Yeah.
No damage was done.
All right. So remind me, do you remember, Mike, what the last thing you said was? Because I had a point to prove, but I don't know what it was at this point.
I said that I think that... all right, I've had drinks. I think that we all agree with this that
Yes.
Pluto should not be defined as a planet. You were going to say something about that. I don't know.
I was at a point, and it was a big point.
Look,
But let me, Liz.
Okay.
Let me just say this. Definitions are fine, but okay, I think I have a general idea where I was going with this. We don't. So myself, Mike, Liz, people that listen to this podcast, and at this point, if you're into this, fucking 50 minutes into the hangover, I don't know. You kind of care about space as well. You don't give a shit about definitions. You don't care. It exists. You want to learn about it. It is interesting. However, to the general public, it needs to be classified as a general planet to be deemed interesting. But you cannot have 145 planets in there. It needs to be 7. It needs to be 9. It cannot be more than 10.
I don't think we need to concern ourselves. Look, I don't think we need to concern ourselves with the general public thing, because look at how many people voted for Trump.
No, you don't.
No. I think the importance of these classifications, I think it's important we have these classifications, because that just shows how our understanding of different planetary bodies has grown, has evolved. No, you can't, because you've been talking for a minute.
30 fucking seconds.
Yeah, so I think it's important that, by observing Pluto since 1929, when it was discovered and named by a 12-year-old girl, classical,
she named it. She didn't discover it.
Yes, and named by.
Oh, I didn't.
In classical reference to a Roman god of the underworld versus the Greek version, which is Hades, but all planets are named after Roman gods. Anyway, the fact that we have evolved our technology enough to be like, hey, we could look at Pluto, but oh wait, there's this other shit out by Pluto. Hold on, let's think about our definition of a planet, because we never had one, really, since the beginning of astronomical observation. We've never really had a definition of a planet. So this is kind of like the first step of a definition of a planet, which I think is a pretty good first step of a definition of a planet, whether
really good.
The amount of clearing its orbits is defined or not. And I think these classifications matter because it helps us further understand our evolution of planetary formation, of planetary system formation, as we observe other nebulae with planetary formation happening, or exoplanets. And while maybe we don't necessarily need to apply this to exoplanet systems, I think it's important that we have this sort of drill down into, okay, these are planets that we know, which are distinguished by these characteristics.
You're buffering.
I'm buffering or I'm bluffing. Versus just everything's a planet because it's orbit the sun. I think it's important that we have these distinctions, and it helps us refine our understanding of the universe in itself.
Right. I think all because you learned that Pluto was a planet when you were a kid in school.
A kid doesn't mean anything.
So here's hold on. Here's my general question. Where does it end? The Higgs boson, after 50 years of being theorized, hypothesized, actually is the best word, was discovered by CERN. Mm-hmm. Do you then take it to the public, the general public, and say, hey, we discovered this thing. Is this the Higgs boson?
What do you think it is?
What do you think it is?
If you're asking me, Liz, I think it is the failure of education on the general public.
To
understand that science and its understanding changes day to day, week to week, year to year.
Yeah,
This is how it works.
Our education system
I haven't
sucks.
spoken for a while. May I?
Our education system sucks, and we need to the general public's opinion really doesn't matter on scientific topics.
It does.
It does
No,
not.
it does not.
100% does.
It does not.
Only in terms
funding?
of funding.
Of funding and of acceptance of what is fact. Now, fact, of course,
No,
does
because
not.
if that was the case, then,
Wait.
sorry.
I'm saying sorry.
No,
Fact
go
does
ahead,
not
go ahead,
change.
Brandon. Go ahead.
Fact does not change whether or not you believe it or not. Whether or not 1 billion or 7 million people believe it. Fact is fact is fact is fact.
Yeah, but the general public
However-
believe every fact is what they believe in, not what
Right.
is actually fact. You can't trust the general public because they voted Trump in for president. So let's
I
not
agree.
fucking
So,
I agree.
trust the
I
general
agree.
public
I
with
agree.
anything
even
scientific.
even
It doesn't
removing the
matter
asshole
what the
that is
general
Trump.
public think.
Even removing Trump from this discussion, all you have to do is look at climate change. The public is irrelevant.
May I continue my
so-
fact?
Okay, go ahead.
My issue
2.5 hours.
stems in this conversation we are having. It's a much larger issue, but in the context of where we are at, stems from 2006 and its definition of a planet. Its definition is faulty.
I don't think it's. I don't think it's that faulty though.
No,
It's refined enough to make sense.
It is only faulty in the fact.
Mike, you agree
People,
with the fact
people
that
get
this
mad
third fact-
because
Wait,
they grew up in school going, "There's 9 planets," and now they have to
Mike?
go, "Oh no, there was 8 planets."
I have
that
said
1, 2 made sense. Third could use some adjusting.
It's
okay.
Not faulty.
Okay,
It
hold
could
on.
be refined, but it's not faulty.
Hold on.
Yes.
There is
It's
a
not
big
faulty.
difference between saying that the third definition has to be refined and that you need to make it more scientific and that you can define things, and saying that the public has some sort of view in this.
Public doesn't have any say in
No,
this.
the
This
public-
isn't a
Let me walk that
Science
back.
isn't a democracy.
Let me walk that back.
The
and
public
explain.
is irrelevant.
Facts are defined by the majority agreeing it is so.
No.
Oh,
Facts are defined
wait a
by
minute.
evidence.
That's a broad statement.
Let's do it. Let's do
Facts
this.
are defined
Facts
by
are
evidence.
agreed by the majority saying it is so.
Then Jeffrey Epstein, killed himself or was killed?
In 100 years, he killed himself. We have thousands of years saying that these facts are so. So yes, it does matter by
Thousands
what the
of years
majority
based
says.
on
No,
what?
okay. Look, Brandon, you
I'm in.
know how science works. It is not. Science is not
by
a
committee.
democracy.
Science is not plurality.
It is not a plurality of the general public. The general public
Don't
is
know shit.
irrelevant.
General
in
public
this.
or
wait,
dumbass.
No,
Let me ask
no,
this. Let me
no,
ask this.
no.
Wait,
Hold
I
on.
will shut up
No,
in 30
Brandon.
seconds. I will
Brandon.
shut up in 30 seconds.
Brandon, stop. Brandon, stop.
Ooh.
When it comes to things like the Higgs boson, physicists do not. It's not like CERN went to economists and asked them what the fuck they think about this. It's not like they then go
I agree.
to Trump and ask him what he thinks, or
I think-
DeSantis and what he thinks. It is the general public is irrelevant in this.
But I think 2023 is different in that idea spreads faster. The idea of what is certain spreads faster, and what is certain spreads in people's minds faster.
Yeah, but what is
than
certain is not
1850.
true then in the general public
No.
now than what
No.
it was in 1850, because we have so much
But-
misinformation spread through the internet that you can deep fake the fucking Pope in a white puffer jacket.
Right. So how many? Wait. To that point, how many millions of people do not know that image was fake and think that happened?
Yeah, so therefore the general public has no say in what is scientific and what is
No.
not.
But what?
It is the scientists that say
Liz.
what is real and what is not.
But what is real and what is scientific
Okay.
is a different thing, and what we accept is one other thing.
It doesn't matter what we accept.
All right.
It's about
Here's
what
the
the
thing.
facts of.
Here's the thing. The public Yes.
Yes, the public is ignorant. Thank you, Mom.
Yes, but
Brandon,
that
hold
is
on.
what...
The public gets their information from Fox News. They get their information from MSNBC. These are very, to be honest, very slanted views of the universe, the world that we live in. They are opinion pieces.
Yeah.
MSNBC.
If you ask the Smashing Pumpkins, the world's a fucking vampire.
No, MSNBC and Fox News and CNN and all of these people are opinion pieces. Science does not work that way.
It should not
Wait.
Science, no.
Let me ask one question.
Answer it. Ask it.
What is truth?
What is truth?
What is true?
Gravity.
This is.
What if gravity's wrong?
Prove it.
Jump off a building. Please don't.
Oh.
Or
make it a short
Jump off your
building.
balcony right now. See what happens. I dare you.
No, by the way, I'm
science.
I completely agree with you. I'm 100%. But I enjoy this conversation.
Look, Brandon, what is true is such a philosophical question.
Yes.
That is irrelevant. Okay.
It's irrelevant to truth.
I don't think it is.
It's irrelevant to science. Okay, so you know what?
Science?
No,
Let's do this.
You know what? I can say that climate change is not real. That's the truth. In fact, that is what a lot of people believe. The problem is science. That statement of science. Okay, so you're saying that what is truth? Climate change is not real. There are only 8 planets. Galaxies don't exist. The Big Bang never happened. These are statements that you're making that you are saying is quote unquote truth, but they're really just hypothetical statements. Hold on. Everybody just let me talk for a second.
He has to get it out.
These are just statements that are it was goddamn drinks. But anyway, no, these are just statements that aren't truth. These are hypothetical statements that then need to be tested by science.
Yes.
And the results of experience, the results of experiments become quote unquote truth.
Look, like if we're talking about the definition of planet, it's like a rough draft. You know, we have enough information to make an adequate rough draft, but we don't really have the information versus observational information of the universe and of the planetary systems to make a...
I completely agree with Mike's point of view. I agree with Liz's definition. We're all on the same page. But the only way science and the public opinion is expanded is if we poke holes in them to create better. So my point of view is that the general public will agree with what is fact.
Have you actually looked at history?
But okay, hold on.
In our current
hold on.
In our lifetimes, in 200 years, it may be different. It will. Wait, I don't say it will. It will be different in 200 years. But currently, the public agree with what is fact.
I think
it's not correct, but they will agree with.
I think we're talking two different things. I think Liz and I are talking from we are approaching this from a very scientific point of view.
I got a piece so bad.
Go do it. We will.
Oh no, I'm in.
We will continue to talk.
Keep going.
I think that Liz and I, we are approaching this from a very scientific point of view, where the evidence leads us, and it's not a democracy. Science is not democracy. Science looks for an understanding of the universe in a mathematical kind of way. It looks for an understanding of how the universe works. Mathematics
Wait.
It has nothing to do with what Mike George thinks, what Liz Davison thinks, what Brandon Riddle thinks. It has absolutely nothing. Science, which is based on the language of mathematics, has nothing
Science,
to
which
do.
is based on science.
Which must be verified by experiments. Does not care what I think.
Pluto doesn't give a
what
fuck.
You think. What oh God, who was the guy?
I agree.
Who was the guy who led Voyager? He was the PI on Voyager.
Stone.
Who?
Steve
Stone.
Steve Stone.
Stone really believes that Pluto is a planet. Mitchell really believes that the moon did not form from he doesn't believe that
The
it
giant
formed
impact
from
theory?
an great impact.
But how would it form?
Well, he believes that it co-formed with the Earth.
But that doesn't make sense.
No, but hold on. What
its context does, but however,
what we believe is irrelevant. And so because what we believe is irrelevant, the public, the larger public, what they think is irrelevant, sure, politically, what they believe actually does become relevant, which is, I think, what Brandon might be saying. I don't know. But that is a political statement. It is not a science statement. It's not
political as we know
statement.
Politics today. But let me take things home.
Let him pause it.
Let me pause it and take things home. I completely agree with Mike. I completely agree with Liz as well. I'm being an asshole in positing these other points of view.
I really think we need to do this as like an actual episode. This is a great episode. And we fucking did it as a hangover.
I've loved it.
And I'm drinking all your drink.
We're 3 hours into this, folks.
You can have some of it because I've had too much.
Eat your bread.
I don't have any more.
No, this was a great. We didn't even get into my stars collapsing.
No,
thing.
we focused on Pluto and the definition of planets.
Mitchell, nothing. So let me take things home here.
Okay.
Not that. Okay, if you're still listening in the YouTube at this point,
podcast
you're
mom
either
is
one of us or some better being than we currently are.
Oh, okay. All right. I do have a question. All right, Liz, Pluto a planet?
No.
Mike, Pluto a planet? No. Brandon?
I think the definition of planet is shitty.
No,
Oh,
it's a
okay.
yes or no
All right,
motherfucking
you've said that.
Yes.
question.
No, I will say yes, but only because I think the definition of planet is terrible.
All right. First of all, Jack, we'll see you later.
Bye,
We'll see you in a
Jack.
couple of weeks.
Bye, Jack. Miss you.
But
I think the definition of
no,
is shitty.
no, that's
So
not
given
my
its current
that is-
definition.
that
Earth
is
is not
not
a
my
planet.
question.
Jupiter has its Trojans. It's not clear its orbit. It is not a planet.
Oh, you want to bring up the Trojans? Okay, if you add up the mass of all the Trojans,
It's a false
No,
host.
we're not talking about math. We're talking about the definition of the IAU.
No, there's not enough. Compare
No, I
Jupiter
agree.
to Pluto.
So we're not talking
Surrounded.
about
Surrounded.
has the mass exceeded Jupiter? Of course not. But that is not the definition.
no, okay, that actually
Is it
is true.
surrounded in its orbit by billions of other objects? No.
Yes.
So,
No. The Trojans around
Probably.
Jupiter, they're
So-
in specific locations and there aren't billions of
Yeah,
them.
but billions of what do you
Alright.
describe? Wait. What
I
do
mean,
you
Pluto's
describe
in
as
its-
an object?
Pluto's in its-
Is it 1
Pluto's in the
centimeter?
Kuiper Belt.
Is
Pluto
it-
is
is
in
it
the
1
Kuiper Belt.
centimeter?
No,
Is it
you
2
see-
centimeters?
is in the
Is
Kuiper
it a
Belt.
millimeter?
I don't think your definition includes
for-
centimeters and
I
don't think you talk about that type of
I
in
have
terms
a
of the
pipe in
radius
my
of the
hand
object.
and feel I'm important.
What?
Is
I
that
said
make
I
you
have a pipe
important?
in my hand and pointing it,
That makes
and I
it
feel like I'm important.
Okay, Gandalf.
I feel as if the size needs to be described.
Yes, but
Yes.
but I think it
Yes.
needs to be described in terms of mass
Agreed.
because
I agree.
because mass can actually determine it has a great effect on size.
Right.
Size
And then, if I may posit, may I posit?
Okay.
Posit.
If I may posit, let us move forward to the year April 9th, 3023.
Okay.
If I may.
2,000 years.
Hastily.
If I may.
Years.
And humanity has garnered technologies and infrastructure from Titan, from Europa, from all these other moons, brought it back to our orbit, and somehow, through the huge orbit of the Earth, its technologies that orbit along the same orbit create a mass beyond the Earth.
This is what I call. This is called
the Earth no longer a planet?
Hyperbole. I'm gonna hyperbole. I call you out on hyperbole.
That is such a hypothetical.
Ask me in the year 3000.
I will.
Okay. All right. I will do that. But I'll be dead. I'm gonna be dead
in that sense, the orbits around the sun does not matter. Correct.
No, it's the mass.
The mass around the sun in its specific orbit, which plus or minus 5 degrees around the sun does not matter.
All right. Anyway,
Brandon.
I think this has been a fabulous episode.
It really has been. This has been an amazing.
We gotta go to that.
We are gonna keep talking about this later on.
It's gonna be so
we will
text.
be. This is
Texts
not
are gonna be
stopping.
happening.
It's been fun. I'm gonna go pee. Y'all do Drink Cosmos on Instagram and everything else on the other things. Enjoy. The shot is a lot of fun. Listen to that. I will see you then, my good sirs.
All right, we'll see everybody.
Bye,
Cheers.
everybody. Thanks for joining us. Follow us on other things.
Follow me on Twitter.
We'll see you next
Drinking
time.
Cosmos, everything else, Cosmos.
I really gotta go pee.